Welcome to foss-north, the virtual edition. We would like to thank all our sponsors and partners in this difficult situation. Our gold sponsors, Luxoft and Ansible by Red Hat. Our silver sponsors, ITRS Group and Make It Right. Our base sponsors, our partner projects, the open source community and the region of Gothenburg. And a huge thanks to our awesome community. This would not have been possible without you.
Good morning everyone and welcome to the last day of foss-north 2020. First on stage is Chris Simmons, who will talk about Debian or Yocto, which is best for your embedded Linux project. The stage is yours, Chris.
Hello, good morning, or at least it's good morning for me. It could be a different time in the world for yourselves. So here I'm here to talk about embedded Linux operating systems, and I want to do a comparison between using Debian and the Yocto project. So let's have a look through and see what this is going to be about. Skip that, skip that. So I'm going to look at the dilemma as to which of these two you should choose. And I'll go through the pros and cons. I'll look at Debian first, then I'll look at Yocto, and then I'll try and draw some conclusions. And I'll be happy. I hope we have time for some questions at the end. So if you have questions, please go ahead and ask them on the chat, and I'll respond to them later. So the dilemma. So here I am. I'm designing my new gizmo, and it's going to be running Linux. I've decided that, but which Linux do I use? I want it to work as quickly and as effectively as possible, but I also want it to be robust and updatable and maintainable. So I know there are lots of options out there. Which one do I choose? So I'm boiling it down to basically two options. You can go off the peg and use an existing desktop-based distro, such as Debian, or any other distro of your choice, Fedora or SUSE or whatever. Ubuntu is quite popular too. They're all basically the same in that they are off-the-shelf, fully ready to run distros. Or you can go bespoke. So rather than taking something that exists already, I can build my own distro from scratch. Using Yocto project is the most popular, but there are other build systems, including Buildroot, OpenWRT, and a few others too. So let's look at Debian first of all then. So Debian is a full distro. It's been around for a long, long time. It has many, many tens of thousands of packages. It has a good support infrastructure, and it comes as a bunch of binaries. So you don't need to mess around cross-compiling stuff. You just install the packages you want, and you're up and ready to go very quickly. So Debian as an embedded OS, it has support for a bunch of architectures that are useful to us. So x86 64, ARM v8, that's the 64-bit ARM distro, essentially, ARM architecture, I should say. ARM HF, which is ARM v7, which is covers all the Cortex A series processors in 32-bit, and the old ARM EL, which supports the ARM v4T instruction set. Really, you shouldn't be using that, but hey, if you do, it is still supported. And you'll find Debian as an option on a lot of dev boards. The most obvious would be Raspberry Pi. Now, Raspberry Pi is slightly different to the others in that it has its own Debian distribution called Raspbian, which is actually compiled for the ARMv6 instruction set, which makes it compatible with the processor used on the first Raspberry Pi and is still used today on the Raspberry Pi Zero. If you're using BeagleBoards, then yes, they all come with a Debian distro as an option, and the same applies to many, many other dev boards. So if you're using Debian, the typical approach is to take a root file system, which you got with a board, Raspberry, for example, and then you can use commands like apt install to install packages. So if I do apt install XYZ, that will go to my the list of upstream repositories in my etc apt sources list file. It will then query the repository, and it will be looking for a file, typically the name XYZ underscore some version number underscore the architecture, and then .deb, deb being the package format used by Debian. And you can do this something very, very similar with Fedora, except those will be RPMs, and you'll be doing a DNF install or something. So I've got my gizmo, I've got my board plugged in, running Debian. Now I want the system to be doing stuff. So I take the off-the-shelf distro, and then I start installing stuff. There may be some things in there that I definitely don't want, so I might want to strip out. Maybe I don't need a word processor. Maybe I don't need the media players and such like. So I strip out all the stuff I don't want because it just gets in the way. And then I go through and install the additional things I want, the various graphics utilities I might need, the libraries, support for various languages, and so on. I may have some code that needs to be compiled natively, something C and C++. So I'll go through and compile those. And typically I would do that on the target board itself, because the target boards, these distros, they have a full development environment. They have GCC and G++ and everything else. Then add any other tweaks, startup scripts, various other configurations. And at the end, we produce an image we call the golden master. So this golden master now has everything configured correctly. It does what I want, it runs my applications, and I'm ready to go. So I take my golden master, and then I take a copy of it. I can just use a simple command like dd to take an exact copy of that file image, disk image, and then just do use dd again to clone it to all the units that I'm shipping. So that essentially is job done. So what can go wrong? So the golden master, wonderful though it is a little bit tricky to reproduce and to maintain. So first of all, the things we did a couple of slides back, probably we never wrote down exactly what we did. Even if we were fairly meticulous, there would be some steps that we skipped. So if we want to make changes to the golden master, we have to do it incrementally. So we boot at the golden master, add a tweak here, add a package, change a configuration file, and then we create a new golden master from that. That's all very fine until we want to make some kind of major change. So if we want to completely replace the golden master with a new version based on a later version of the underlying operating system, then that's hard work, because we then have to go through and reproduce all the stages we went through earlier, remembering that some of them were not actually documented. So there'll be some trial and error and some fiddling around to get it right. So there is a very big incentive to stick with the golden master as it is, using the version that was shipped. Not only that, when you create such a thing as a golden master in this way, there's usually some kind of fingerprint left by the person who created it. For example, there may be some user accounts and passwords which weren't cleaned up. There may be some history left in the .bash history file for some of those users. There may be some log files left lying around from previously. And all of these things can be interesting and useful to somebody trying to hack into your system. So really, the golden master is not the best way to do it. If you really want to use Debian or a similar distro for your embedded system, let's have a look at doing it in a slightly better way. So we need something that's robust and reproducible. So essentially, you can do this. After all, people build Debian. The Debian people themselves build Debian from scratch, so it must be possible. So you would take a thing like rootstock or dbootstrap, which gives you a minimal Debian image. And then based on that, you would start adding in the bits and pieces that you need. Ideally, you would do this in a scripted way. So either use an off-the-shelf script, or you write your own scripts or whatever. Some examples of this would be, for example, the BeagleBoard image builder. And there's a link there. That is essentially the bunch of scripts used by the BeagleBoard people. And similarly, for Raspberry Pi and Raspberry, they use Raspberry Pi Gen. So you could have a look at either one of those and use that as a basis for building your own from scratch, run once script to generate your own Debian from its component parts. And that will be much more robust and reproducible because you can just run the script again, change the Debian version number, for example, and with a few tweaks, it would build. This is slightly off topic, but I just want to say a quick thing about software update. So this is a common thing we need once we start shipping our products. Chances are we're going to want to be able to update them either over the air or even just directly using a USB stick and just going around and updating each individual machine. So how do we do that? So with Debian and similar distros, it would seem to be fairly easy. You just run apt update to update to a later version, and you can apt-get any additional packages that you want. But be aware that this is not a complete solution, or at least not in all cases. The problem with package-based update is that the updates themselves are not atomic, which means that, excuse me, which means that if you, for example, you lose power or the system resets halfway through an update, there's a good chance you'll end up with a corrupted system, which will either not boot or boot and not run the app anymore. There are many solutions to this. You can do a full image update, exactly as you would do with the Octo project, as we're going to come on to in a few minutes. You can also do some clever things with containers and flat packs and snappies and all that kind of stuff. However, I just want to point out that if you're using Debian, package update is probably not what you're going to be wanting. So what else is wrong with the Debian approach? It does tend to build larger images than if you do the same thing with Yocto. And that's because the Debian images are meant to be generic and to work on a wide range of systems. And so inevitably they have stuff that's common to a large number of their use cases, but which may not be needed in your particular use case. And that means more software means more attack vectors. It means there's more software to protect. There are more things that can go wrong. Also, the distro repositories, although they do support typically ARM processors and various other CPU architectures, they usually use a common denominator approach. So, for example, with Raspberry, we just looked at, that is compiled for ARM v6 for compatibility reasons with the Raspberry Pi 1, but it does mean that you're not, if you're using the OS as exactly as it is, it's not taking advantage of the instruction sets of the later versions of the Raspberry Pis. It's just using the subset that is compatible with ARM v6. Next up, these operating systems are not really optimized for using flash memory. still believe that they are running on hard drives. And so they will do a lot of stuff, they'll do a lot of disk writes, and eventually that's going to wear out the flash memory. The worst case here is log files. Log files are really bad for flash memory. The problem is that whenever you do a write to a log file, usually they're quite short writes, small writes, you then have to do a flush to make sure that the log information got written to the underlying storage. And every time you do that, you're going to be forcing the flash disk controller to do an erase cycle and actually commit it to flash memory. And as you may know, flash memory, you can only do a certain number of erase cycles before it goes bad. On modern flash drives, it's quite a small number. It's about 3,000 erases typically for each cell. So, yeah. So just to come back to the topic then. So writing lots of small log files, writing log files with lots of small writes will tend to wear out flash memory. So one of the things you may need to do is to go and disable or rationalize the logging, for example. Another thing would be swapping. You really don't want to swap onto flash memory. And then the last thing on this topic then, if you're not using a cross compiler, then you're going to have to compile on the target, which in some ways is nice and easy because you just install the dev libraries you need and run the compiler, but it is going to be slow and you're probably going to run out of memory. So you may have to set up some swapping to some disk storage somewhere. Oh yeah, and don't forget that the distros generally just cover the base operating system. You'll probably still have to build the bootloader, whichever that may be, U-boot for example, and the kernel modules. Depends on the distro. If you're using a distro such as Raspberry, that indeed will update the kernel and U-boot, but in the general case, you'll have to add that in yourself. Okay, so that's the Debian side of the story. Let's have a look at the Open Embedded and Yocto side of the story. So the idea of Yocto project is that you create a distro from scratch. You give a set of rules, and it will then go and generate whatever you have specified. And it builds everything from the source code. So rather than using precompiled binaries as with a regular distro, we're going to be taking the upstream source and cross-compiling it for whichever target you have selected. This has the advantage that we can optimize for the processor architecture we're going to be running on. We have complete control over the whole thing. Yocto project is pretty well supported. It has been very successful over the last 10 years in getting support from the main processor manufacturers. It supports all the main architectures, ARM, MIPS, PowerPC, and a few others. And there's also commercial support available from a whole bunch of other people, including the ones mentioned on the slide. So going to building your root file system, your distro, the way you do this with Yocto project is, Yocto project basically is a bunch of metadata, information about how to build things. And the most important part of those are recipes. And then there is a tool called bitbake, which, given some global configuration files saying what kind of thing you want to build, you can bitbake a package, and bitbake will then read the metadata. It will download the source code from wherever the source code comes from. Typically, that will be a tar.gz file. And from that, it actually generates a package. In my diagram, I've shown it as being an RPM file, but you can actually change the packaging format to be Debian or IPK if you so wish. But those packages are really only used for build time. They're not really intended for runtime installation. So the final stage of building a Yocto or Open Embedded System is a task called do root fs, and that will take a list of all the packages that you want to put into the final root file system. It will extract the information it needs from the RPM file, and it will create the root file system for you. And then that is your golden, well, I was going to say golden master, that's the wrong thing. That is your root file system. You will then install that on your target hardware, and away you go. So I just want to talk a little bit about the metadata, just to give you a bit of insight as to how this all works. So there are three main variables associated with generating a Yocto project distro. Sorry, Yocto project image. They are machine, distro, and image. So the distro variable is literally a variable called distro equals, and you give the name of the distro you want. The distro is controls the basic policy of how we want to put things together. So what kind of init system do you want to use? Is it going to be System D or System 5? Do you want to use the latest version of everything, or do you want to use more conservative version control, and so on and so on? The next one, the machine, this has information about the target hardware. So it will have information like what architecture it is, what tuning flags you should use for GCC, which bootloader you're going to be using, and the file system layout and that kind of stuff. So all low-level machine-based stuff. And then the third variable is the image. So an image essentially is a list of packages, quite a long list of packages of the software, languages, libraries, etc., that I want to be installed into my root file system. And the nice thing about these three variables is they are independent variables. So I can change any one of those three things, and I'll get and I can build using that. So, for example, if I have two different dev boards or target boards, I can just change the machine variable for each one of them, leave the distro and the image the same, and I will get the same operating system compiled for each of those two boards. And they could be completely different architectures. One could be x86, one could be an ARM-based system. Likewise, if I have a bunch of images, maybe a dev image for development and debugging, a production image, an image for a particular customer, then I just need to create the image variable for that, the image recipe for that, and then I can keep the distro and the machine the same and just pump out the images for the different target use cases. So the whole thing is very scalable. It's easy to customize once you have the basic system set up. There are some downsides from all of this, got to say. So everybody says learning Yocto project is tricky, and it kind of is. It's hard to say. So yeah, you've got to put some effort into doing this stuff. It's not just a question of doing a few apt-gets as you can with Debian. You've got to understand the system to some degree in order to set those variables up. So yeah, you've got to invest a bit of time and effort in understanding how Yocto works. The support window. This has just got better, actually. So the Yocto project now has, starting the end of April, the end of this month, there will be the first long-term support release of Yocto project. And that will be supported for 2 years. Nevertheless, that is still shorter than the support window you get with a typical distro such as Debian. The Debian long-term support team will actually support the operating system for 5 years typically. So you'll need to have a plan as to how you're going to bridge that, how you're going to support your operating system into the future. Oh, and I should say on that, you can do that yourself. But there are also a lot of commercial organizations, including the ones I mentioned earlier, such as ENIA, TimeSys, and a few others, that will give you professional support for this, for Yocto project. The next issue. The process of building a Yocto image is quite lengthy. And at least the first time you do it, it's going to take some hours, and it's going to require a fairly powerful computer to do that. So you'll need to have the hardware available to do this and to run these builds on a fairly regular basis. Okay, so that's the two alternatives, Debian or a similar distro versus building from scratch using Open Embedded and Yocto project. So now I want to try and build some conclusions from all of that. So I would like to say then that for Debian, the real advantage from Debian really is that you can build the system and have it up and running very, very quickly. So Debian is great for proof of concept. It's great for prototypes. It's great for one-off projects where you're not going to be distributing huge numbers of them. And it's also great if you're using commodity hardware such as Raspberry Pis, BeagleBones, BeagleBoards, etc. Correspondingly then, I would recommend Yocto project if you are designing your own hardware and you want to create a distro for it from scratch. Yocto project does exactly that. With Yocto, you can actually lock the system down very effectively. Yocto root foss systems tend to be quite small and tend to have only the exact software that you need. So you have the reduced attack surface. And the people writing the recipes for Yocto project and Open Embedded do tend to be from the embedded community. And so they will have in mind optimizing for to reduce disk space, to reduce storage rights, and yeah, basically do the things you need for an embedded system. One little handy thing that Yocto and similar things do is they all have an option to generate a license manifest. So you just run the appropriate command, and then that gives you a list of all the open source licenses that you are using in that to build that particular image. So that's handy when you want to do your due diligence and say, well, exactly which licenses are we using here? For example, GPL v3 can be an issue in some cases. So this gives you that information off directly. You can do, of course, a similar thing with Debian distros. You can go through and extract all the licenses. But to my knowledge, there isn't a way to do that very, very easily. Okay, and that is literally it. So I've actually gone through this talk about twice as fast as I thought I would. So we are into the question time then.
Okay, thank you very much for this exhaustive comparison. I myself have been using Yocto at work for at least 6 years or something, and I can really say I'm a fan. So we do have two questions here. The first one is, it seems that Yocto can produce a Deb-based systems. How would that compare to Debian? Can you merge those two worlds?
No, is a simple answer.
Okay.
So Yocto does not create Deb-based systems in the way that you're thinking. So it, as I showed on the diagram, the bitbake takes the upstream source code and produces packages from it, usually in RPM format, but you can also set it to be Deb. But that doesn't mean to say that is a Debian operating system. It just means it's using Deb as a packaging format. it is in no way a Debian operating system. So the answer is no, you can't merge those.
Okay, then let's go to the second question. In Debian/Raspbian, you can use apt-get to install additional software from their project servers. How would you do that with Yocto?
So there is an option with the Yocto project to install a package manager, which can either be RPM-based or Debian-based. So it's just another component of the software. And once you've installed that, you can then do, for example, apt-get from your Yocto project distro.
But then you need your own servers, or how does it work?
Well, okay, yes. So that's the front end. So yes, you would of course need a back end. So you would put the packages that you want to update onto your own server. You would set your sources.list to point to your own server, and it would then, when you do an apt upgrade or an apt install, it would download from your servers.
And resolve all the versions, compatibilities, and so on?
Yes, it would do the normal dependency checking, and it would install dependencies in the normal way. However, I would like to say you probably don't want to do this. This is not the recommended way.
Okay. Thank you. Then Tobias asks, what if you install something like Mender /FW update on Debian-based systems? Is it possible to combine the best of the two worlds?
I'm not entirely sure I understand the question. So Mender.io is one of several update mechanisms commonly used on embedded systems. And the way it does the update essentially is using a full image update. So you typically have two partitions set aside for the root file system, the one you're using live and the one that's ready for updates. When you apply the update, you apply it to the second, or the B image as we call it, and then you tell the bootloader to swap A and B over, so the next time you boot into the new image. And that works for Yocto project and for Debian-based systems and various other things as well. So I don't fully understand the meaning of the question, but you can use Mender image-based update and other image update mechanisms on both Yocto project and Debian-based systems.
Okay.
Did that make sense?
Hopefully to the to the person who asked.
If not, please please ask a follow-up question.
Okay. So yeah, once it shows up, but that was all the questions for now, at least. Thank you again, and I'll give over to Johan.
Yeah, thank you a lot. It was very nice having you here. We will now have a small break until 10 when the next speaker comes online. So see you then.
Welcome to foss-north, the virtual edition. We would like to thank all our sponsors and partners in this difficult situation. Our gold sponsors, Luxoft and Ansible by Red Hat. Our silver sponsors, ITRS Group and Make It Right. Our base sponsors, our partner projects, the open source community and the region of Gothenburg. And a huge thanks to our awesome community. This would not have been possible without you.
Welcome back. Next up is Victor, who will tell us about Screenly. Victor, welcome. The scene is yours.
Thanks so much. This talk is about Screenly OSC, which has become the most popular digital signage project on GitHub. And this talk is about the backstory of Screenly and how we came to be where we are today, essentially. And just to preface this with what digital signage is, because it's a common question that we get, digital signage are these screen-to-screen retail environments, as well as in the tube and so on, where they display advertisement or dashboards on. So that's what digital signage is. So this talk is about that and how we became to be the most popular project on GitHub. So before I begin there, let's start a bit about who I am. I'm an entrepreneur, been doing Linux-ish stuff for the last decade and a half or so, built a few companies, and this is one of them. And I'll walk you through a little bit what other things I've been working on in this talk. So before we begin, let's do a little bit of a history lesson on the company behind Screenly and what enabled us to do this and how we actually ended up doing this. So Wireload is the company behind Screenly, the parent company, and we've done a bunch of things over the years. We started out doing something called Yippee Mail way back when in 2006, when I was still in college, doing email migration in a project called Yippee Move, which Yippee Mail converted into. We then ended up doing a project called Blotter, which is a desktop calendar. I'll show you in a second. And then we ended up writing Screenly. And Screenly then became its own project in 2018, its own company. And then we eventually sunset Yippee Move. Yippee Move was a email migration tool that we made helping customers move between email systems, allowing customers to move between, say, Gmail to Hotmail to Gmail and things like that. Had some initial traction there, got some TechCrunch coverage, which is kind of cool, but it's not really a topic of this conversation. Same with Blotter. We did some pretty well up there. We're number 4 in productivity in the US in the Mac App Store, and actually in Sweden we did rather well as well. As you can see in the screenshot here, we were number 12 in the Mac App Store in Sweden as well. So it did rather well. So the company itself, fully bootstrapped. We never took any external investors. And as a very timely reminder, I guess, is that we have been remote since the very first days. So we actually started as a remote company well over a decade ago, way before remote was cool. So we've done remote work over a decade. And as it turns out, that's been really helpful for trying to help manage or try to build and manage an open source project. So those are some quick backstory on Screenly and the company behind Screenly. But let's talk a little bit about how Screenly came to be. And it actually started in Sweden in a project we did with, or an acquisition we did with of a Swedish company that we accidentally ended up acquiring, really, because they were about to go bust. So our first exposure to digital signage was this company. And it was a really interesting technical project in one sense. And we discovered a lot of things about the market. This project we took over was a small company with 10, 15 screens. And when we looked at their existing software stack, we were kind of horrified. It was not a great stack. It used, just to give you a sense of what it was using Flash as the playback mechanism and Windows-based players along with RDP to remote manage these systems. And it was very fragile, and it was not a very technically savvy product at all. And to make matters worse, we had 30 days after the acquisition to the go live and no software to run. So that was an interesting technical deadline to solve. So we basically had to figure out, what do we do and how do we run this in 30 days without customers being upset when their advertisements were not running. So we started doing some market due diligence. And what we found was that there were two buckets of digital signage solutions. One of them were the traditional black boxes. So you have the traditional large companies like BrightSign, where you buy this very expensive black box with their proprietary software on, and you hope for the best, essentially. You don't have much control over it. The other bracket you had was the hobbyist bucket and the open source bucket. And at the time when we started this, Zibo was the most popular one. And it was not a very clean technical slate. It was, if I'm not mistaken, it was very hackish PHP with some MySQL backends. It didn't really, it was very, very duct tapey. So we looked at this market and we said, well, we could probably do better than this, because this doesn't feel like a very good fit. So we started to look at what kind of hardware we can get to run this. So we looked at the Asus ePC back in the days, and this is back in 2011, 2012. And the Asus ePC, if you guys may remember, it was one of the first affordable Linux-enabled PCs. And it ran, it ran out of the box, it ran Linux, was available as a Linux version. So the drivers and everything worked. So that was a good choice. We then picked up on some 3G modems for connectivity, because these devices were scattered across on the countryside, so we could not rely on solid connectivity. So we basically had to rely on mobile connectivity to get these to work. Then we started gluing a bunch of tools together. Being an old Linux person, having played with Linux for a long time, it felt like the natural way to hack together a prototype. And here's where it gets kind of interesting, because we actually did learn quite a few things here. The plumbing for the playback turned out we ended up using MPlayer, as you guys are probably most familiar with. We then ended up using FFmpeg to re-encode a bunch of videos so that it could be played back on MPlayer well. And then we ended up using Cron to actually schedule a lot of these things. So that's something that we ended up finding rather useful for this tool. We then ended up using rsync to push out content to devices. And the last one, well, next to last one, is my favorite, which is the @ command, which I'll dive into a second, because it's kind of a hidden gem in the Linux toolkit, really. Then finally, we used Puppet for configuration management. And the total BOM price for these units were around $300, which compared to other alternatives out there was rather affordable, actually, because the hardware we were replacing costed a lot more. So we had these devices that actually worked and cost about $300 per unit. So that was actually a pretty decent BOM, and actually worked rather well. So before I go into how this turned into ScreenLink, because this is basically the precursor to ScreenLink, I'm going to dive into some nerd trivia of things we discovered while we built this. And the first one I already alluded to, and that's @ command. And the @ command is actually similar some ways to the cron tab, but it allows you to run the command at a given interval. So you can say, at this particular time, run this command. And I frankly think that most Linux P users today are unfamiliar with this, and it's actually a kind of handy tool to have at your disposal if you need to do something that for some reason you can't do with the cron tab, or with SysMD timers these days, I guess. So that was one of the interesting learnings that we ran into while building this system. What other thing we discovered was when you start to manage these fleets and build them out, Now, it was only 10, 15 devices, but manually installing all these devices turned out to be rather complex. So automating and streamlining installation turned out to be rather important. So we built up scripts using Ubuntu or Debian Pre-Seed, which allows you to entirely automate the installation, which simplifies the setup a lot. So you can say things like, I want to install these packages, I want the system partitioning to look like this, I want to enable this, and then you can have any configuration to look like this. So it allows you to fully streamline the installation of a Linux system. So it's very handy for both for desktops and for devices where you want to do this at scale. Next was the cellular modems. And let me tell you that it sucks to deal with cellular modems. They are extremely reliable. We ended up trying to standardize things as much as possible. We ended up using a Huawei modem. I think it was an E220 or something like that. But what we learned was that even if the modems are branded the same way, they can have very, very different firmwares and hardware within them that you can't even discover by looking at the actual modem. So even if you buy them in the same store, you can't rely that it's actually the exact same hardware. We ended up spending a lot of time on writing fallback mechanisms for these modems. And the problem is that even with all these fallback mechanisms, with reconnections and all that stuff, we ended up in a number of times a situation where you can literally not do this remotely. You would have to physically unplug and plug in back in the modem. And this is kind of crazy, you would think, but that is the reality of these modems. They literally require a physical hard power switch, power cycle. So my advice to you, if you're trying to do something similar to this, is avoid USB modems at any cost. Instead, what you should be doing is use a router. There are a bunch of different companies out there that do USB modems. They're even more common today than they were back then. Back then, they cost quite a bit of money, but these days you can pick them up for close to nothing. And instead of connecting over USB, you just connect over Ethernet or Wi-Fi, and that's a lot more reliable because all these modems tend to have a lot better logic built in. But I guess one of the good things was that I actually got to brush up on my haze commands that I haven't touched since the VBS days. So that was kind of interesting. That was kind of fun to learn more about that, and got to get some more exposure to Minicom, which is another tool I hadn't used for many, many years. So that was, I guess, the positive side of that. Next, a side note on Puppet. My recommendation there is just don't. Puppet, I've had a lot of bad experience with. It's extremely hard to scale, and not for this particular 10 nodes, but in other contexts, we've had issues scaling it. So my recommended is avoid whenever possible. Now, how does this bring us back into the Raspberry Pi? Well, at the end of 2011, when we started this project, because our go live date was January 1st, 2012. This is just before the first Raspberry Pi was announced. The first Raspberry Pi was announced, if I'm not mistaken, around March of 2012. There was a long wait list to get these devices, but eventually I was able to get a hold of one of these devices in summer or spring 2012, so relatively early on. And what turned out to be so interesting is that the Raspberry Pi turned out to be the perfect device for digital signage. Even before we started looking at the Raspberry Pi, we were actually looking to scale up this company and scale out a digital signage solution. And we were actually looking to design our own hardware. So we've already started to spec out what would our ideal hardware look like. And as it turns out, the Raspberry Pi came very close to that. There were very few things that we would have changed with regards to how the Raspberry Pi is designed for making it a perfect playback device. And one thing we could have never gotten to ourselves would have been the price point, because this price point is something you only achieve at scale. So at the $35 price point, plus accessories, of course, the Raspberry Pi was an insanely cost-effective device. So even with accessories, we're looking at less than $100 per device, which is insanely cost-effective compared to almost anything else out there. Today, it's slightly different because now you have a lot of competitors in the SPC market, but back then that was definitely an insanely good price point. What's more interesting is that it had a very, very low power draw. And the power draw makes it very compelling for a lot of use cases, of course, but for signage, you don't want to draw too much power because that adds to your cost of operating system, of course, and in particular if you operate at a larger scale. But perhaps the most important thing here, or one of the most important things, was that it ran Linux out of the box, which meant that we could repurpose almost all our tooling for the Raspberry Pi without too much effort. So there's no real blocker here for us to actually move to this system. But what we really wanted to do as well was to be able to play 1080p video playback, because back then 4K wasn't a thing. 1080 was the highest you do, and even to this day 1080 is still kind of the golden standard for signage. So we basically had to do 1080 playback, and Raspberry Pi did that just phenomenally well, and it supported H.264 video codecs. So what's the catch, really? We were thinking, like, is this really that straightforward? Well, we didn't actually find the catch. I'll dive into some catch we found later in the latter part of the talk, but generally speaking, there was no magic catch. It really worked perfectly well out of the box. So porting our player to the Raspberry Pi, it turns out it wasn't that difficult. It definitely required some rewrites of our toolchain. It required some modifications, some optimization, because Raspberry Pi, in particular in the early Raspberry Pi, you only had one core, and you only had, I think it was 256 megs of RAM that was shared with the GPU. So you didn't have a lot of RAM to operate with. So there were definitely some optimization required compared to running on an ePC, which at the time had, I think, 4 gigs of RAM and dedicated GPU memory. So we had fewer resources, but that was basically came down to tweaking and optimizing our toolkit so that we didn't consume or waste resources. And as so happened, most software we needed were already available. The only really big difference that we had to do would be to replace MPlayer with something called OMXPlayer, which is basically a fork of MPlayer for the Raspberry Pi. It's still the most prevalent video player for the Raspberry Pi, except for the Pi 4, which is a separate kind of worm that I'll go into later. So we did look into this, and we decided that, okay, let's spend some cycles on this. And I think we wanted to make sure this actually is a sustainable project. So we ended up, in addition to porting the software, we ended up writing a web interface to it. We ended up writing some improvements there. We deprecated some of the hackish parts of it. And then we packaged it up into a project on GitHub. And this was basically like, this was still a side project for us. We essentially looked at solving our own problem to start with, but we thought, well, maybe we just open source it and see what happens. So this is the initial post. As you see, July 5th, 2012. We posted on the Raspberry Pi forum. Back then, the Raspberry Pi forum wasn't as big as it is today, but that has been essentially the post basically kickstarted our entire project. This post today has over almost 400,000 views on a forum, and has about 1,100 posts in this particular thread by itself. So this has driven us to where we are today, essentially. So it's an amazing, if you manage to get into this and leverage this community, it's insanely powerful. The Raspberry Pi community is, yeah, it's probably one of the most strongest communities that I've ever seen, to be honest. So if you manage to get on the right side of the community, you can get a very long way. And just as a walk down memory lane, this is the very first commit to our open source project back in July 25th, 2012. So this is when we open sourced it. So that's the very first announcement of this. So what happened? We basically hit it out of the ballpark. This particular post on the forum, combined with the GitHub repository, just exploded. To be honest, we did not anticipate this at all. We started off thinking that this could be a side project, but very quickly we realized that, okay, we're onto something here. People are loving it. And it was one of the first projects for the Raspberry Pi that were more than a hobbyist project. And I think we are the first company to fully endorse the Raspberry Pi as a commercial project. And I'll dive into that more later. But our open source plus commercial model, which I'll dive into a bit in a second, is probably one of the first companies that will be able to adopt the Raspberry Pi. And so we hit it out of the ballpark, and this just drove an insane amount of traffic. And it has, to this day, I'm not sure how it is today, but until recent at least, it used to be one of the most popular Raspberry Pi, popular threads on the entire Raspberry Pi forum. And this by itself led us to become the most popular digital signage project on GitHub. So project like Zibo, like I referred to before, Screenly OSC has now become much more popular than that. But one of the more interesting things that happened out of this was because of our traction. Within weeks of open sourcing this, we started getting requests from commercial use cases. And one of the more interesting calls we had in the early days was a company out of the US calling us up and saying, hey, we're operating an ATM network with, I think it was something like 20,000 ATM machines. And they were interested in actually running Screenly on those, because by adopting Raspberry Pis, instead of running them on x86 commodity hardware that they were doing before, they were going to save somewhere around the lines of $600 or $700 per device or per ATM. Now, that particular project didn't work out for commercial reasons because they wanted to own the IP, but nonetheless, it was a really interesting indicator for us that we're really onto something here, and we really want to make sure that we are capitalizing on this. So looking at the growth of the project, and if you can see, we are now at almost exponential growth in GitHub history, in GitHub stars. And that's something that's really exciting to see. Like, community is really picking up on this, and we start to see a lot of momentum being built around here. Now, it is kind of important to dive into how we're going to monetize this, because open source projects by themselves are difficult. They're not cost effective. They can be cost effective, but it's really expensive to run and manage them. So in order to support the effort that we need to put into this, we essentially have to have a commercial offering. And commercial open source can take many shapes and forms. Some offer it through paid support plans. Others offer it through commercial extensions. We decided to have two different versions of Screenly, one for commercial use and one for open source use. And when I say commercial use, it doesn't mean that you can't use the open source version for commercial use. It just means that we only provide community support for the open source version. But if you want commercial support, you have to go for our commercial version. So Screenly Pro is our commercial version, and Screenly OSC was great, but users wanted to manage multiple screens with a single interface. That's something that we didn't have in the open source version, but something that we added in the commercial version. But one of the most important thing was community support is not sufficient for many customers. Business users don't want to wait for somebody volunteering to answer their issues when their screens are down. They want commercial support. They also want a turnkey solution, such as automatic security update and automatic updates, and they were happy to pay for this. And this allows us to spend money on OSC. So by having a commercial version, that allowed us to both have an open source version and a commercial version, so we can build a company around this. And that's exactly what we did. We started to allocate resources and build out a company around this. So looking at Screenly Pro versus 1 then. So we started forking OSE into a commercial version. We started with very rough device management. And I mentioned Puppet before, and I kind of took a stab at it. And that's where we started with that. We actually started running Puppet at rather large scale to manage these nodes. In retrospect, that was a horrible decision because scaling Puppet is actually rather challenging, and it becomes difficult when you cross 10,000 nodes. It becomes rather challenging. So we started to move to other tools later on. So scaling ended up being hard, and it ended up being rather difficult with technical debt as we moved from the open source version and patched into the open source commercial version. But we managed to scale it to thousands of screens, and we managed to build out an entire team to support it. So that's how we basically managed to bankroll Screenly OSC and how we managed to maintain that project. With that, I'm going to take a quick detour on how we then did a rewrite on that. So we basically rewrote the entire code from scratch. We incorporated all lessons. We did not want to reinvent the wheel, like things that doesn't seem very difficult or people don't think about in there when they're building out an open source project. But things like over-the-air updates are rather challenging, actually. Making sure a fleet is updated, making sure you have transactional updates. Those things are rather challenging. When we started working on Screenly, there were really not a lot of tools out there for this. Now, there are a lot better tools out there. There are things like Ubuntu Core. There are things like Balena's framework for updates, and there are some others around that as well. So now it's a lot easier to do these things, both for the open source version and for the commercial version. But when we started, there were little tools around this. So we wanted to have commercial operating system and unified seamless playback and transitions between assets, which turned out to be a rather highly requested feature. One of the other things was that security turned out to be something that we really wanted to focus on. And this is true for the open source version as well, but it's harder to do in an open source environment than it is to do in a commercial environment because we can't really control the player fully. But as you can imagine, in an open source, in a digital signage world, you have essentially as high exposure assets that you can have. You have screens that are facing highly visible areas, and if these screens are to get compromised, that is really bad. And we've seen countless examples of that over the last decade, where people have taken over these screens and display porn or whatever, maybe some blasphemous messages. And as an operator of those screens, that's obviously reflects extremely poorly on you. So that's essentially what we did with Screenly OSC, with Screenly Pro. But let's go back to Screenly OSC and talk a little bit more about that. So open source communities can be amazing. We saw that with our Raspberry Pi posts on the Raspberry Pi forum. That essentially built up our entire system and built up everything around Screenly. And it's amazing what can happen. Like that drove a ton of traffic. It drove a lot of interesting conversations, and we saw a lot of interesting use cases. But there's a downside to open source as well, and that is you tend to have at times you see very entitled users that want a lot of free things and not give anything back. And that can be, it's challenging as a product manager to deal with this. Because on the one hand, you want to help your community thrive, but on the other hand, you need people to help out in order for it to be thriving. So it's difficult at times to deal with people that are that expect everything to be built for them, and they expect a sense of urgency without giving anything back. So dealing with that has been one of the bigger challenges that we've dealt with, in particular when when it's critical for them, but they don't want to help out themselves. They just want everything to be fixed. So that has been something that we have struggled a little bit with, to be honest, building out our community here. The other thing is documentation. And I think this is something that we have probably not spent enough time on documentation, because it's important when new users come in and to be able to find everything. And what we've done has been largely around community building. So we built out forums, and we built out that and tried to crowdsource for a community. We've tried to crowdsource our documentation in a sense by having a community in a forum. But it's not really enough, because we need to make sure that's better. So what we are doing right now is try to hire people to manage our community better. And that's part of that is documentation, because I think that's how you can really make a community thrive, by having better documentation. So that's one of the lessons that I think we need to be better at, and was something that we are working on better. And having dedicated community managers to help with this is really, really important, I think. Now, lowering the barrier for new developers is another really important point, because it is easy for us that are familiar with the code base to think that it's easy, but it is rather challenging for a new developer to jump into a project. So this goes hand in hand with documentation, because documentation comes in two shapes and forms. You have the documentation for end users, which is super important, but you also have the documentation for developers. You can solve that with some test coverage and tests and so on, but you still need good documentation. We have done an okay job at trying to clean that up, I think, but we still have a long way to go to make it better. But it is definitely something that I think a lot of projects that I've been looking at myself as well, it can be challenging to get involved with. So try to lower barriers for new developers. That's a really important thing, I think, here. The other thing kind of goes hand in hand with this, which is try lowering the barrier by having good test coverage and automated tests. This is a good way for people to actually find mistakes in their code, of course. And depending on your background, writing tests and so on may or may not be obvious to you, but it's something that is important when you try to onboard new developers. Keep it simple. That's really, really hard, and I've struggled with this myself, I must admit, because it's when you're hacking on things like this, it's very tempting to adopt the latest technologies and play with the latest and greatest tools. But what you are doing to some degree is to isolate yourself from or block out a lot of people. So trying to keeping things simple, even if it's not very sexy, trying to keep things simple can definitely help with regards to building a community, because there are a lot of developers out there that are not perhaps so well versed with the latest or don't care about the latest and greatest technologies that perhaps I would count to myself as one of the people that try to always stay up to date with the most current technologies and whatnot. But the reality is that a lot of people are far more pragmatic about the skills they acquire. And for them, if you are using too many new technologies in your tooling, it might actually backfire. And I'll give you some examples that we've been very heavy on Dockerization, for instance, in Screenly, and that may or may not have been a mistake, because we've seen, even when we talk into the community, that a lot of people are kind of scared and don't really understand Docker, even though for me it feels like it's something that's been around forever, but in reality a lot of people are not familiar with these kind of technologies. So that's one thing that we have learned. Try to keep things simple, dumb it down if possible. It's also, this gets really complicated when we talk about security. And this is a personal thing that I struggle with myself, which is security is important, particularly in a project like this, because the impact of having poor security and things getting compromised is reflecting poorly on the project. And if somebody has to audit the project, that reflects poorly. But having too tight security and too much focus on security may also scare away too many developers. So it's a tough balancing act. And an example of that is, if you want to have like SSL certificate, like self-signed SSL certificate, and you do logins over that, how does that impact security? So there are lots of things there that it's difficult to do in these projects. So try to be pragmatic about this. And I personally struggle a lot with these projects on this in the project. Another thing that people don't really realize, or a lot of people don't realize, that running a successful open source project requires fairly significant financial resources, or it requires a lot of your time. If you start to, if you don't have developers working on your project, paid or unpaid, your project's gonna die. And you basically need to either allocate your own time to it or have paying somebody to do it. And that's true for both actually committing code, but also manage the actual project. So we think that because we have our commercial version, we have been able to allocate resources towards this. But for a lot of projects, it's tough, right? If you're trying to do this based on purely on donations, I don't think it's possible. Maybe it is for some projects, but it's extremely difficult. So one of our advice for building a thriving open source community is honestly finding a way to monetize it, so you can actually have the resource to do it. So that could be in the shape of having a commercial version with some bells and whistles that you don't have in the open source version, or it could be in the shape or form of having commercial support, but you need to basically find a way to monetize it. Otherwise, I don't honestly see how it can actually work out in the long run. Because if you have to keep your day job and do this, it's extremely challenging. I mean, I know a lot of people have managed to pull it off, but it's extremely challenging. So that if you have a smaller scale project, you kind of need to do this and find a niche that actually works out where you can actually monetize it. So that's a big learning that I think some underestimate. So having both paid developers and paid community managers, if possible, is a key learning for us. And then take good care of your contributors. Building contributors is not a trivial matter. It takes a lot of time to find them. It takes a lot of time for them to build up the confidence to work with you and putting in their own time. So taking good care of them is super important. And we do that in a number of ways. We try to do it in a number of ways. One of them is simply giving them swag, right? Giving them products like t-shirts and whatever that may be that you have, and that can go a long way. Giving them shout outs for like good work. That's super important for them to feel valued, because that's really, really important. But managing contributors is kind of challenging because it becomes difficult when, depending on how strict you are with your code quality as well. Like, how do you deal with code quality that is less than where you would like to be it to be? It's challenging because sometimes it feels really bad to reject something that somebody put in long hours towards writing, because the code is not there. And obviously, sometimes you can mentor them and coach them to get it up to standards you want it to be, but sometimes it's not possible, and that feels bad. But so taking good care of good contributors is really, really important, and that's something that we really try really hard to work on. But it's not a solved problem, and I think it's something that a lot of open source projects struggle with, in particular before they reach massive scale, where they have large-scale contributors and a community of contributors that can provide peer reviews and feedback. The next advice and learning is stick to popular languages and frameworks. This kind of goes back to what I'm mentioning before, which is it's easy to jump on the latest, coolest framework or flavor of the month, but it really shoots you in the foot. You really shoot yourself in the foot by doing so. It's much better to stick with tried and true technologies, even if they're not very sexy. So, case in point, in retrospect for Screenly OSC, we should have probably stuck to something like Django, Python's Django, instead of writing our own stuff. That would have saved us a lot of time, and it would have made it a lot easier for third-party contributors to help out, because now all of a sudden you have a framework that a lot of people are familiar with, and it makes it easier to contribute. So try sticking to languages and frameworks that are popular. And we have had a big benefit of having our tools written in Python, because Python is currently a very thriving language. So we've had a good benefit from that. But that's the learning I would say. Like, if I were to do a new open source project today, I would definitely stick to something tried and true with regards to frameworks and languages. The next part is something that's maybe not as obvious to a lot of techies, but content marketing is super important. It's being able to get coverage in various blogs can help you drive a lot of traffic, which drives exposure, which drives engagement. So we've done a lot of things over the years for Screenly OSC. One of them being partnering with various platforms. We've worked with we worked with content marketing sites like Hackster that helped us drive a lot of traffic, for instance, and just creating really interesting projects around your product. So like interesting use cases and interesting projects that can help drive a lot of content, help drive a lot of engagement and finding you a lot of new users, and that in turn can help make your community thrive. So I think that's a really important lesson that I think a lot of open source projects are missing. Some projects are doing it really, really well, but some projects are neglecting that. And I think they could really benefit from doing more content marketing and writing blog posts and guest posts and so on. And I think that goes kind of hand in hand with partnerships. And this sounds maybe too commercial for a lot of people, but partnerships with similar projects, like we've done a lot of collaboration with, partnership may be the wrong word, but collaboration with Balena, for instance. And they've had a lot of reach, and that has spilled over to us, and that has helped us drive a lot of engagement and driven a lot of users for Screenly OSC. So I would think that's really something that I would recommend as well. Reach out to other open source projects as well, and see how you can collaborate with them and integrate with them such that you have a spillover effect from them. That is a really, really powerful tool for you to engage with. And by allowing you to tap into and integrate with other popular open source projects, you can definitely build your project and ride on their wave of success. So that's kind of goes hand in hand with content marketing, but if you could do integrations like that, I think that's a great way to build improved traction. And the last one is actually a really important key takeaway here. And that's, don't assume new contributors or contributors at large are familiar with modern dev flows. And this is something that we've learned the hard way, actually, because it's easy to live in a little bubble where everybody's familiar with GitHub, everybody's familiar with GitHub pull requests. The reality is, however, that a lot of people are not. We get surprisingly many people that want to contribute to Screenly that are not familiar with Git, they're not familiar with GitHub. And it's easy to get into this bubble where you assume everybody knows this. So this kind of goes back to documentation, because having good documentation for how a contribution should be done, what tool you need to do this, and how to familiarize with this, that can be super helpful. And we found that we have to educate a lot of people on this. And it surprised me at first, because I was living in this bubble where everybody's familiar with these tools, but in reality they're not. There are a lot of developers out there that are, maybe they're just hacking on the side and they're decent programmers, but they're just not working on a startup where they use these tools. So helping users and develop users' skills around modern development workflows can be very, very helpful. That's how you can get a lot of contributions from people who otherwise would not be able to contribute. So that's something that we've learned, actually. And I was, like I said, I was surprised by how many people that were unfamiliar with this, but don't assume people are familiar with modern development tools. Help them out, because that really can help drive engagement from other users you would otherwise not be able to do. All right, those are the last ones for the community building there. And then I have some learnings from Raspberry Pi as well. First of all, SD cards suck. That's the reality. If you gotta try to run anything commercially on Raspberry Pi and expect to run for a long period of time, you will find out very quickly that SD cards break very fast. They are notoriously unreliable, and they will break. It's just a matter of time. And you can get better by having class 10 SD cards, and you can stick to certain brands that are better than others, but eventually they will break. There are industrial grade SD cards, but they're insanely expensive. So your better option is to essentially reduce the number of writes to the SD cards. And I think that's probably your best chance of extending the lifespan. We've done a lot of work in Screenly to reduce this. So having like read-only partitions and read-only as much as possible definitely helps with the lifespan. If you're familiar with Raspberry Pi, you're probably familiar with Raspbian. If you were to use Raspbian for your project, make sure that you do not run the defaults. There are a lot of default configurations that are not great, in my opinion. I would say things like swapping obviously needs to be turned off. Otherwise, you're going to completely destroy that SD card. But there are a lot of tweaking to be done. Happy to take up anybody afterwards to help to speak more in detail about that. Lastly, well, one of the last things is no, your phone charger, your old phone charger is not as efficient power supply. The Raspberry Pi draws a lot of power actually compared to your phone, so you cannot use a regular USB phone charger. You need to have a proper one. We've seen over the years a lot of stability issues related to this because if you have a power supply that is not strong enough, you will see a lot of really strange behavior, like random power cycles, GPUs functioning, and so on. So make sure you get a proper power supply. Lastly, the lack of RTC or real-time clock can be really painful. So for those not familiar with it, the real-time clock is basically what keeps track of the time, which means that when you turn on the computer, it knows what time it is because it has a chip where it actually stores this with a battery. Now, the Raspberry Pi does not have this, which means that every time you power it on, it has no idea what time it is until it has been able to communicate with a network server where it receives the time from. This can be really painful, in particular when we're doing something like signage where time is super important. So that's it about the Raspberry Pi. Finally, about the Raspberry Pi 4. In my opinion, it was rushed out. It is not necessarily ready for prime time yet. Still missing some drivers. It has some really, really bad hardware issues in the early days, which some of them have been addressed right now. We have still not adopted the Raspberry Pi Raspberry 4 fully. But I'm happy to chat with anybody about Raspberry Pi 4 afterwards if there are any particular questions around that. And with that, questions.
Okay, very nice. Thank you.
Thank you.
So we do have 3 questions here.
Sure.
So the first one is, why did you decide to use video instead of rendering on the device and getting just the data via internet?
Oh, for the video playback. So the video is it's an interesting question. So first of all, there are a number of reasons for that. First of all, the customers provide the videos themselves. So they already provide us with those video files. The second one is we've designed an entire system, and this is an important one, to be offline, able to run offline. So whenever there's an internet outage, we can't stream things and so on. We need to be able to have it locally on the devices so that it will be able to resume playback even if there is an outage. So I hope that answers the question. If not, let me know.
Okay, thank you. Then Tobias asks, how much is the interest in Screenly Pro comes from the features it has versus the other benefits such as support, etc.?
That's a very good question. I don't have a good answer for that, but I think they go hand in hand. I think users who do want larger scales, if you are operating on a commercial level where your screens are essential to your business, I think they go hand in hand because commercial support is kind of important. If things are going down, you want to make sure you have a touch point where you can reach out to and they can resolve the issues for you. But the features themselves are also important because if you operate at scale, like we have customers that have like hundreds of screens, then obviously that is super important to have those functionalities. Now, we have seen people who have built their own system on top of Screenly OSC because Screenly OSC does have an API, so you could reinvent some of the features and script your way through some of the features in Screenly Pro. But what we've seen is that commercial users tend to prefer a commercial arrangement more so than writing their own tooling on top of the open source version. So I think they go hand in hand, to be honest.
Okay, great. Thank you. The next question is, how much time/money do you say that you save by engaging the community instead of writing the code yourself? Do you gain quality?
That varies a lot. We've had some really good contributors. And I mean, sometimes you could definitely save a lot of time. Sometimes it takes a lot of time to get people up to speed. We have some long-term contributors that are basically like whenever they open a pull request, we just accept it almost right away. There are usually few comments on it. Whereas for newer contributors, there's a lot of things that need to be explained. So I think it varies with how new the contributor is. So newer contributors, there's always a learning curve. In which case, it's not cost effective for the first X times, oftentimes. But as they get more engaged over time, it becomes, you get a payback on or return on investment on that time you put in on teaching them and coaching them. So I think it depends how long they stick around, I think, is the answer to the question, and how seasoned they are to start with. We've had first-time contributors that are flawless directly, and there are really seasoned developers, and they really get the gist of everything. But for less seasoned developers or seasoned contributors, there is some coaching. If they stick around, then we get a return on investment.
Okay, cool. Then the next question is, on your comment about the lack of RTC in the Raspberry Pi, what's your proposed solution for that? Manually adding a tiny RTC?
Yeah, that's one solution. We don't require an RTC for us to work. We require a network connection, really. But it has been a problem because a lot of enterprise in particular, and a lot of enterprise in particular have very tight policies around NTP servers. And this comes from the fact that NTP was abused for DDoS a few years ago, 2 years ago, whatever it was. So a lot of companies are very conservative about NTP allowance in their networks. So that's where a lot of these problems come from. In that situation, usually it's better to just tell them that I need to reconfigure and set an NTP server. That's one solution to it. We've had a few conversations around the open source version in particular, where they want to use them completely air gapped. This could be where they want to run them, say, in the middle of nowhere without any connectivity. We've had a few instances of that. And in that case, adding an RTC is probably the only solution that we can offer, because if you are running the device completely in isolation without any network around to talk to, and you can expect power cycles, then the best solution is to add an RTC. So that is what we recommend in such solution, yeah.
Great. Then the last question is, what did you swap Puppet with?
So for Screenly Pro, we ended up using Ubuntu Core, which is a fully transactional system. So we basically mitigate the entire configuration management tooling for it. So we don't have a configuration management tool there. That took care of the OTA and everything. So that's what we solved with in Screenly Pro. In Screenly OSE, because we don't offer any fleet management there, but we do use actually Ansible locally for the installation methods. Now, I'm not super pleased with Ansible there either. I mean, Ansible, in my opinion, is a step up from Puppet, at least in terms of usability, but it is very slow on the Raspberry Pi. So that's our short-term solution and what we have been used for Screenly OSE for some time as part of the installation. However, the aspiration on Screenly OSE is to deprecate that as well in favor of just having containers, because that would speed up things a lot in terms of installation and in terms of ease of use as well. So we are right now in midst of rewriting the runtime environment to run inside Docker containers. But running Docker on ARM can be challenging at times, in particular building it up and so on. But that's the answer is that we're looking to build it out using Docker containers instead going forward.
Okay, interesting. Okay, thank you very much for your talk.
Thank you.
I give over to Johan back.
Hi, yeah, thank you to everyone. We will do a quick speaker change and we will be back at 11. See you.
Welcome to foss-north, the virtual edition. We would like to thank all our sponsors and partners in this difficult situation. Our gold sponsors, Luxoft and Ansible by Red Hat. Our silver sponsors, ITRS Group and Make It Right. Our base sponsors, our partner projects, the open source community and the region of Gothenburg. And a huge thanks to our awesome community. This would not have been possible without you.
Welcome back. So next up is Drew, who will talk about RISC-V and running Linux on it. The stage is yours, Drew.
If you haven't heard of us before, we have actually a nice way to certify your projects if you're building something that's open source hardware. So you can find out more information about that at certification.oshwa.org. So if you've not heard of the term before, open source hardware is hardware whose design is made publicly available so that anyone can study, modify, distribute, make, and sell the design or hardware based on that design. So I mostly do electronics. So for an electronics project, the documentation for an open source hardware project would include the schematics, the board layout, and the bill materials. And for the schematics and the board layouts, it would be important to share the editable source files. So I use a program called KiCad, so I'd be sharing the KiCad files, or if you use Eagle or Altium, you'd be sharing the files from your CAD program. The reason for that is if you want other people to be able to collaborate on the development, then it's best for them to have the original CAD files. Additionally, you want to publish your bill of materials so that people can actually build the project based on the parts list. And one thing to keep in mind is if you want other people to be able to build your project, make sure that they can source the parts in low quantity. I go more into open source hardware in this CCC talk that I gave at the last Congress. So there's a link in the slides, and on the next slide here, I'll have a link again. There's a PDF in a GitHub repo with the links to a bunch of the different stuff in the presentation. Because a lot of these are going to have links in these slides. So if you want to find out more, you can click on the link. So RISC-V, let's talk about that. So when you write a C or C++ program, it gets compiled into instructions for the microprocessor or the CPU to execute. But how does the compiler know what instructions the CPU understands? This is defined by the instruction set architecture, or the ISA. So an ISA is a standard. It's a set of rules that define the tasks that the processor can run. So you've probably heard of x86, such as Intel or AMD or ARM. So if probably your laptop or your desktop or most servers are x86 based, so they have an Intel or AMD processor. They're using the x86 instruction set, or your smartphone definitely has an ARM in it. So that's a processor that's implementing the ARM instruction set. However, both of these are proprietary and need commercial licensing if you want to be able to use them. In the case of x86, only a few companies are even able to use it. In the case of ARM, you have to license it from ARM. So about 10 years ago, some researchers that were doing computer architecture research at the University of California, Berkeley, wanted to have an ISA that they could use for doing their research. And they didn't want to bother with having to license the commercial ISA like the ARM instruction set. So they created RISC-V. So it's called RISC-V because it's the 5th RISC instruction set to come out of Berkeley. Berkeley was involved in creating the original RISC instruction set back in the early 80s. So RISC-V is a new instruction set that is free and open for anyone to be able to use. And I believe it's licensed under the Creative Commons share-alike license. If you want to find out more about the instruction set, it's a pretty brief presentation here, but two great talks that I recommend. One is Instruction Sets Want to Be Free, which is from David Patterson, who's one of the people that actually created RISC back in the early 80s, and he's been involved with RISC-V. And then Kirst Asanovich, who's the professor that kind of spearheaded the RISC-V project. In every, probably maybe once or twice a year, he gives the State of the Union of RISC-V. So if you just punch that into YouTube, you'll find the latest one, or you can pull up the link there. So this is Kirst's talk that he gives kind of once or twice a year, called the State of the Union. And I'm just going to pull some slides in from that to give you a good idea. So one of the ideas behind RISC-V is that it's a simple instruction set. That they took all the knowledge they had over several decades of designing RISC instruction sets to kind of make the best one. The idea too behind RISC-V is that it's modular. So the idea is it's going to scale from tiny little 32-bit microcontrollers all the way up to supercomputers. So something that's modular and extensible. So there's a small base, and then there's extensions that allow you to add in additional functionality. The other thing that's important too is the base, which is frozen now, means that if you compile a program for the RISC-V based instruction set, it'll continue to work even if you have some new fancy processor like 20 years from now. Just to give you a sense of the timeline here, it started about 10 years ago, and then they've been doing some tape outs of research chips along the way, and then at some point companies got involved like Western Digital and NVIDIA. And the other really important thing, I think, when it comes to RISC-V, is not the first open instruction set, but it's really gained critical mass. So there's support in Linux and GCC and Clang, a bunch of different real-time operating systems. So there's the support there when it comes to the software side of things. There's also several open source implementations of it. So the ISA itself is just a standard of what instructions can be run on the processor, and then there's an implementation of that instruction set. So there's several open source implementations that are out there. Rocket and Boom are from Berkeley. Risky and Arion are from ETH Zurich. And then there's also companies like Western Digital has one called Swerve that they've contributed as well. So both universities and companies are creating open implementations. Though I should note that while the instruction set is open, there can be both open source implementations and proprietary implementations. So just because it says RISC-V doesn't mean that the design of the processor is open. It just means that it's implementing the open instruction set. So to give you a sense here of what is the base ISA for RISC-V, so the base ISA is just 32-bit fixed with integer. So that's all you need to have to be considered RISC-V is just this base ISA. And to give you a sense here, this is all the instructions for the base ISA, which is referred to as RV RISC-V. 32 is 32-bit, and then I for integer. If you have used ARM or x86 especially, you'll notice there's a lot more instructions in this. So this is a pretty small subset here, which is the idea here is that RISC-V is simple and the base is very small, and then it can be extended as needed for different use cases. And from David Patterson's talk, he has this what's called the green card here, which was back in the day when people do machine coding, they would have the list of all the different instructions for the instruction set. And the idea here is that you can represent the whole breadth of RISC-V with just this little card here. So this covers everything from 32-bit, 64-bit, even 128-bit. Now, we don't have 128 bits of memory yet, but the idea is in the future, it might be useful, especially for security. The 128-bit has some benefits there. So there's already some people that are experimenting with it. When you look at RISC-V architectures, you see all these letters, and it can get kind of confusing. M is for multiply, A is for atomic, F is for float, D is for double float, and then C is for compressed. So you'll see a mix of those depending on what features it implements. And you can always go back to these talks if you want to learn more about the RISC-V ISA. So let's talk about who's using RISC-V. So As I said before, the idea here was to have an instruction set that would be extensible from everything from a small little microcontroller all the way up to a supercomputer. And all these things are being done right now with RISC-V. While it was created at Berkeley, the RISC-V standard is now maintained by the RISC-V Foundation at riscv.org. There's over 400 members, including companies and universities and more. And one of the things that's really helped me is they have these, used to be called RISC-V Workshop, now the RISC-V Summit, once or twice a year. And all the talks are up on YouTube. So if you want to find out more, it's a great place to look. And companies like NVIDIA and Western Digital are looking to ship millions of devices. So for example, Western Digital decided that they were going to take all the little controllers that are in their disk drives and move them over from architectures like ARM over to RISC-V. NVIDIA also is replacing a controller in their GPU with a RISC-V based controller. Not the thing that does the heavy lifting, but just something that coordinates and manages the hardware. And part of this is to avoid ARM licensing fees. So if you're making 1 billion devices, that can add up. But more importantly, is it gives them the freedom to leverage open source implementations, like ones from Berkeley and ETH Zurich. And also gives them the ability to implement their own microarchitecture the best way for their own products. So with ARM, only a few companies like Qualcomm and Apple have architecture licenses. Everyone else is just licensing specific cores. So with RISC-V, you have the liberty to do your own microarchitecture implementation. And as I mentioned, the RISC-V Summit, it happens, I think, once a year. There's other events as well. So if you check out the RISC-V YouTube channel, you can find a ton there. It's one of the ways I'm able to stay up with what's happening in the RISC-V community. And one of the other things I think is interesting with RISC-V is it's something that we're seeing growth globally in. So one of the reasons I think is countries and nations have an incentive, I think, to have technology that is developed internally. So nations such as India have created initiatives to make their own processor designs based on RISC-V. And this way they can mitigate the risk of depending on technology that's coming from another country like the US. And something that happened last year was the US banned companies from doing business with Huawei, which is a large company, a very large company in China. And for a while, it was uncertain if Huawei would be able to continue to use ARM or not. Currently, they are still able to use ARM, licensed ARM cores, but you have to imagine that this probably gave a good incentive for companies in China to look at alternatives, and many of them are now implementing their own RISC-V designs. I should mention Alibaba especially is designing a server class RISC-V chip. So if you want to learn more about RISC-V, wrote a column in a recent Hackspace magazine. You can download that for free off the internet at that URL there. And the first time that I learned of RISC-V was several years ago. I came across this project called On-Chip OpenV. So this was a completely open source design for a 32-bit microcontroller out of a university in Columbia. And the effort was called On-Chip. So this was really cool. They designed the microcontroller, including the analog parts, and it was all open source implementation of the RISC-V instruction set. So that's really cool. But I'm also interested in Linux. So what is out there that will allow us to run Linux on RISC-V? So I was really excited when I saw Low Risk form a few years ago. It was created by a couple of people that were involved in starting Raspberry Pi. And the aim here was to produce a SoC or system on chip that's capable of doing something like running a smartphone or making a basic single board computer around. Essentially a low cost, in volume SoC that we could run Linux on. They're still working on that, but in the meantime, they've also started doing some security work with RISC-V and Google called OpenTitan. Alex Bradbury, who's one of the people that was involved in a lot of the software stuff on the Raspberry Pi when it first started, and is one of the founders of Low Risk, he gave an interesting talk about the future of operating systems on RISC-V that is worth checking out there. In addition, while they haven't created a silicon chip yet, they're still developing this idea of the low-risk SoC. And there's information on this page here that you can go to in the link about how you can take their current release and run it on a FPGA development board and get a full Linux graphical desktop environment. So I'm part of the Open Source Hardware Association, which is mostly typically focused on like board level projects, but the complement there when it comes to chip design is FOSSi, which is the Free and Open Source Silicon Foundation. And the idea here is they kind of bring together a lot of the different organizations and people working in RISC-V and open source chip design. And they have several conferences throughout the year, such as OrgConf and LatchUp. LatchUp is in the US and OrgConf is in Europe. And then sometimes they do these other one-off conferences as well. If you click on the link there, it'll take you to the FOSSi Foundation's website, or if you pull up FOSSi in YouTube, you can see all the different talks that have happened at their conferences. And one of the initiatives out of FOSSi is a website called LibreCores. So the idea here, with source code, many people will share their projects on GitHub, but there hasn't been a great place to go and find open source chip design on the internet, especially things that have been proven that they work and you can reuse in your project. So LibreCores is something that's trying to solve that problem. It's still a pretty early effort, but I think in the future, hopefully that'll be a place that you can go if you're designing your own chip and you need a USB controller or you need a SPI peripheral, you can go there and grab that and integrate it into your design. So one of the companies that's really heavily involved in RISC-V is called Sci-Fi, and it's a startup that was formed by some of the researchers out of Berkeley. And they were one of the first to come out with a commercially available microcontroller, and it's called the FE310. And they have this Arduino form factor board that they came out with a few years ago. Now this is really cool, but it is still just a microcontroller. So it has, a couple kilobytes of memory. It's not something that we can, unfortunately, it's not something we can run Linux on. So let's talk about what possible RISC-V chips are out there that we could run Linux on. Well, Sci-Fi also made a pentacore 64-bit RISC-V system on chip called the Freedom Unleashed FU540. And they came out with a board, I think about 2 years ago, which is really cool. It has 4 64-bit RISC-V cores. It's a really nice system. The only downside here is this is really just kind of an evaluation board, proof of concept. They only made, I think, less than 1,000, and the board cost $1,000. So it is probably the nicest board you can get right now if you wanted to run Linux on RISC-V. However, it's not practical for most people. However, many places I've seen it are at people that are doing things like bringing up distros. So, for example, there are people working on a Fedora port for RISC-V. And there's a good presentation here from someone from Red Hat about how they're doing that project. And they are actually leveraging that Sci-Fi Freedom Unleashed board along with a graphics card and some other hardware to get a full Linux desktop running. So this is not practical for most people. It's a fairly expensive system, but this is what some people are using to bring up distros right now for RISC-V. So in addition to that real hardware solution with the expensive Sci-Fi board and then some other expensive hardware to get a full desktop, the other thing that people are using is just QEMU. So QEMU is an emulator that allows you to do things like emulate ARM or RISC-V on your x86 desktop or server. So the Fedora effort from the people at Red Hat, they're using both a combination of real hardware and also QEMU. And this is kind of gives you a flavor here for how it works. It's kind of the normal flow that we'd expect, just with the beginning there being something called OpenSPI. And that's kind of, you could think of it as the kind of basic initialization of the system. And that'll go into U-boot, which is a fairly common bootloader that you'll see on embedded boards. And then we jump into Linux, and then we do our normal init ram fs, and then we boot up into Fedora. And if you're a Debian fan, Debian's also doing a port as well. So both Fedora and Debian have working ports right now for RISC-V. So there's the Sci5 Unleashed board. It's $1,000. It's not something that's generally available. So what's something that we can actually get our hands on? So this little board here, it has a chip on it called the Kendrite K210. So this is something that an engineer from Western Digital, Damien Lamal, had worked on along with a couple other people last year to try and get it working. So the constraint here was it only has 8 megabytes of RAM, so pretty limited environment. But right now it's the only thing that's generally available for running Linux on. So it's a dual core 64-bit RISC-V core running at 400 megahertz with 8 megabytes of SRAM, which is a lot of SRAM for a microcontroller, not a lot for a Linux system. The cool thing is this board, you can buy the smaller one here for only $13. It's made by a company called Cypede, and you can get it from different places, including Seed Studio. And Damien, along with a couple other Linux kernel hackers, they got Linux finally running on it. And then probably about a month ago, kind of for a while, it was like this experimental thing that they hadn't really shared yet how to get it working. And then about a month ago, kind of all came together, and now there's really clear instructions about how if you get one of these boards, you can go and load up and put you can put Linux on it, and then you'll finally have a system running Linux on RISC-V here. So here's an example of the board that I have, and just showing you there. It's got two 64-bit cores, and we can even run a little C compiler on there to write small programs. So it's not particularly practical, but for right now, unless you really, our options are using QEMU on x86 hardware, or having that really expensive Sci5 board, or this smaller board. There's another option I'll get to very quickly, which is FPGAs. But in terms of actual hard chips, or ASICs is another term for that, these are our options right now. And the version called the Go board, the Cypede Max Go board, also has a little Wi-Fi chip in it that someone's been trying to get working. It's connected through serial, so the goal there is that we'll eventually be able to have networking on this small system. And I think in the reference image that you can download from here, I think you still have something like 4 megabytes or 6 megabytes free. So there is some room there to do some interesting things, I think. Though if we're going to have something like a Raspberry Pi or a BeagleBone that's RISC-V, we really need a system on chip that's made in volume that has external memory. So the things that are coming up in 2020, Microchip, formerly Microsemi, has this PolarFire SoC. So this is actually a hard RISC-V processor along with an FPGA. So if you've heard of the Xilinx Zinc, this is a similar situation where you have a hard silicon processor, and then you also have an FPGA fabric alongside of it. However, because it's an FPGA, it's going to be, I think, more expensive than your typical sort of system on chip. So that'll be one option, but I think it'll be relatively expensive for people that are used to things like Raspberry Pis or BeagleBones. One of the other things I'm excited about is the Open Hardware Group, which is a nonprofit formed by a couple of different companies. They're creating this board called creating this chip called the Core V SoC, and it's going to be very similar to an NXP IMX. So if you've done embedded Linux work before, NXP, formerly Freescale, is very common with IMX6 or IMX8. And this is essentially that chip, but with a RISC-V core instead of an ARM core. So they're hoping to tape out, which means send to fab, the test chip in the second half of this year. So maybe next year we'll see boards come out with this processor on it. And this is the sort of chip that I think is needed for us to be able to do something like, make a BeagleBone or Raspberry Pi type board with RISC-V. So one of the things I'm very interested in is making a board that's $100 or less, that's capable of running Linux. We can't quite do that now because we don't have a chip yet, but I'm hoping to, once a chip like that Open Hardware Group, Core V, comes out, that we could put together an open hardware board with that system on chip. So if you're interested in that sort of thing, please get in touch with me. I'm thinking of maybe setting up a mailing list or something like that and see what we can get going here. However, we don't necessarily have to just wait for ASICs chips to come out, because we can also use something called FPGAs. So FPGAs are a very large topic. They stand for Field Programmable Gate Arrays. One of great talk from last year was from Megan Wachs of Sci5. So you can check this out. It was from the Hackaday Super Conference, and it goes into RISC-V and also FPGAs. And this is a slide from it that I think is a good kind of quick explanation of what an FPGA is. So you can think of an FPGA, or a Field Programmable Gate Array, as a big sea of gates inside a chip. So normally inside a chip you have like specific functionality, specific functions dedicated to different parts of the chip. An FPGA is just it's a sea of essentially logic gates that we can then reprogram to achieve any sort of digital logic that we design, including even a processor. So we can have something called a soft core, which is a processor core that we load into the FPGA. So I'm going to be talking about solutions where we design a RISC-V processor and then we load it into the FPGA, and we consider that to be a soft core instead of a hard core, which is like designed in gates on silicon. This is basically, you can think of it as a sea of gates that we can take and then through software configure it to be whatever sort of hardware that we want it to be. Now, traditionally with FPGAs, you have to download these really giant proprietary IDEs. Like the one from Xilinx is like 40 gigabytes for even the smallest installation, and it's proprietary software. So in the last couple of years, it was really exciting to see open source tool chains to come to some of these FPGAs. And in the FPGA world, kind of something that's similar to when you compile a program is, instead of compiling your source code, you then do something called synthesis. So you have something called the hardware description language, which is basically a text description of what you want the hardware to do. And examples of this is Verilog or VHDL are the languages that you use to define the hardware. And then you run it through a synthesis process that then produces kind of a gate level design of how that logic is implemented. And one of the first tools that was produced was from a person named Claire Wolf, created a tool called Yosis that allows us to do synthesis with open source tools. And then there's another set of tools for place and route. So using all these things together, we can go from our text description of the hardware, our Verilog, all the way to the bit stream, which is the actual like ones and zeros that get loaded onto the FPGA, all with open source tools. So this was kind of a big revelation when this came out. It was for a rather small FPGA from a company called Lattice, called the ICE40. So there was a lot of nifty things you could do with this, but it's not quite big enough to have a soft core that's capable of running Linux. However, one of the bigger Lattice parts, called the ECP5, later on, there was an open source project called Project Trellis that came along and allowed you to use an open source flow with this part as well. And I'm going to be talking about a project in a little bit where we used that. However, the biggest FPGAs out there and the ones that are most common in industry are Xilinx. And there is even an effort now that's close to being done called Project X-Ray that's going to allow you to have an open source flow for these larger Xilinx parts. I think things will get really interesting once we have these open source tools for some of these larger Xilinx parts. If you want to learn more about FPGAs, I talk more about kind of the basics of FPGAs and these open source tool chains in this Hackspace column that I wrote recently. You can download it for free at that URL. And then specifically, I want to talk about the experience that I had with myself and a couple other people at this conference at the end of last year. So if you've heard of the website called Hackaday, they post a lot of cool hardware projects that people around the world have made every day. And then every year in November, they have a conference in Los Angeles where people get together and do talks and workshops. And they usually have a cool hardware badge. So the badge this year had that ECP5 FPGA in it. which, I mentioned the sea of gates before. So this one has 45,000 logic elements that you can program to implement your design. So just to give you a sense of how many gates are in there in the FPGA that we can play with, this one has about 45,000. And it kind of has this Game Boy form factor. So the idea here was what it came with was some different games you could play, and then it had a little graphics engine that you could program in C to display your name or do little animations and graphics and things like that. And it was super fun. And there was several different workshops that taught you how to do things in Verilog and how to do graphics programming in C. But a group of us were like, that was nice, that's neat, but what we really want is we want to run Linux on the badge, right? Because why wouldn't you want to put Linux on anything that you could? So myself and a couple other people, Michael Welling, Tim Ansel, Sean Cross, and Jacob, we got together and hacked on it for a couple days. And in the end, we were able to get Linux running on the badge. And the first attempt was to use the built-in RAM, which was only 16 megabytes. And we weren't successful with that, but thankfully, especially, it's a hardware hacking conference. So Jacob, before the conference, saw the design of the badge and was like, hey, I'll make an add-in board that has 32 megabytes of DRAM. And that turned out to be very critical because we needed the SD-RAM to be able to run Linux. So we were like, oh, it would work if we only had DRAM. And he's like, well, I made this board. Maybe this will work. And we're like, ooh, perfect. You can see on the back here of the badge. So this is what the front looks like. But then the back had this connector. And the idea here was you'd have cartridges, kind of like a Game Boy had. So this cartridge adds 32 megabytes of SD-RAM. And what we're going to do with this FPGA on the badge is load in a soft RISC-V core that can run Linux. And I mentioned that sea of gates, and I thought this was really cool. Great person on Twitter that's always tweeting about open source tools and FPGAs. EcoTC has a cool image here of what does it look like when we take that sea of gates and configure it to be a soft core, a soft RISC-V core. And this is kind of a macro view. If you imagine zooming out and seeing all those thousands of gates wired up, just to give you an idea of what does it look like at a macro level. But specifically, how did we create this soft RISC-V core that got loaded into the Hackaday badge so we could run Linux on it? Well, we actually used Python to do that. So Tim Ansel, who goes by Mithro, he was one of the people there at the Hackaday Super Conference. And when we were talking about, it'd be cool to run Linux, he, along with Sean, suggested using this framework that uses Python. And Tim has a longer talk where he goes into why Python is great for creating hardware. And his justification is that Python's a powerful language and a productive language. I use Python a lot, and I would agree with that. And we can actually use that to generate the hardware description language like Verilog that you would normally use in chip design. Specifically, we use this framework called MeGen. So MeGen is a Python framework that allows us to easily generate a bunch of Verilog. So instead of having to write in this Verilog language, we instead just use Python, and that produces the Verilog that then goes into the synthesis tool that produces the design that goes into the FPGA. So Python's not running on the FPGA, but we're using Python to create hardware description language that will then produce the gate configuration that goes into the FPGA. So this is just a quick little example from his talk about what does it look like to have a little hello world LED blinker in MeGen. If you've done any sort of digital design before with Verilog or VHDL, you'll probably see some of the similar patterns here. So this is to give you a flavor of what it looks like to do hardware design in Python. I can't go too much into it in this talk because we don't have that much time. But there's a great tutorial called FPGA 101, and the link there is to the GitHub repo with it. And it's both a combination of slides and little tutorials that teach you how to do use MeGen. And to give you a kind of example here, I was talking about VHDL. Both Verilog and VHDL are usually used to do chip design. So on the left there is VHDL of basically defining a flip-flop, which is a very basic digital circuit. And then on the right-hand side is the implementation in MeGen. which is that Python framework. So it's basically an alternative hardware description language based on Python. And what we used to get Linux running on the Hackaday badge was something that's built up on top of MeGen called LiteX. So LiteX actually allows us to create a whole system on chip with all the different parts that we need in there based with this Python MeGen language. So LiteX gives us the cores and the controllers that we need for building a full system. You can find out more on the GitHub there for LiteX. And here's a nice little overview of what LiteX is. So LiteX, we have we're writing Python code in this MeGen framework. And then we also have different peripherals that we can pull in from the LiteX cores ecosystem. So things like Ethernet controller, SATA controller, which we don't have on this badge, but we do have DRAM. So we don't have to write our own DRAM controller. We can use the Lite DRAM controller. And there's fancier FPGA boards that have things like Ethernet and SATA and PCI Express. And for those boards, you can use these other modules from LiteX. Here's kind of a closer up, a picture of this ASCII diagram. So we have our FPGA toolchain, like the open source toolchains I was talking about before, like Project IceStorm, or in the case of this FPGA, Project Trellis. And then we have MeGen, which is that Python framework. And then we have the implementation of different cores, like the DRAM controller from LiteX. And that all gets pulled together along with the definition of our board into the design that actually gets loaded onto the FPGA. However, we were very much aided in the fact that there was already this project called Linux on LiteX VexRisc V. So that's kind of a mouthful. VexRisc V is a 32-bit Linux-capable RISC-V implementation. So this is a open source implementation of the RISC-V instruction set at 32 bits, and it's capable of running Linux. And then this project takes that core implementation along with things from LiteX, like Lite DRAM, and allows you to produce a system that is a full system on chip that can run Linux, and then load that onto an FPGA. So here's an example of what it looks like having Linux on LiteX VexRisc boot up on an FPGA board. And here's an example of Linux running on the Hackaday badge. So in this case, I have a serial port wired up to my laptop from the badge, and I'm seeing the output there of the serial port on the badge. So we have the Linux on LiteX VexRisc on the ECP5 FPGA in the Hackaday badge, and it boots up, and then it loads the kernel, loads the root file system, and then we can interact with it through the serial port in the terminal emulator on my laptop. So after we got back from the conference, it seemed like a good idea to try and upstream the work that we did. So if you're interested in seeing the files that we had to change to make this possible, you can go look at this pull request here. Well, you probably don't have the Hackaday badge because it was only made for the people at the conference. This is kind of gives a good overview of what does it look like to add support for a new board in LiteX. And to give you a flavor here of what the Python code looks like, this is the file where we defined the pin constraints. So this is essentially for all the different hardware ports on the badge, how do those map back to pins on the FPGA chip? So that's what's described in this file. And I think, again, for me as a Python programmer, not someone with a chip design background, this is much more readable and understandable to me than having to look at Verilog or VHDL. It also leverages the nice object-oriented nature of Python. So, you know, you don't have to understand what all these things mean, but you can see here we're in our board, in the definition for the Hackaday badge, we're pulling in things like LiteX, you know, SDRAM, LiteX, you know, clocks and stuff like that. So we're able to pull in these modules that were already implemented and just bring it in for our board, and then just change the little things that are specific to our board and not have to re-implement everything on our own. And just to give you an example here of what does it look like to define a new board in Linux and LiteX VexRisc. So the way we did this is we took an existing board called the ULX3S, which is from a hackerspace in Croatia called Radiona, and they already had a board with the same FPGA, the ECP5. So we took, and they were already in Linux on LightX Fast RISC, so we just took that board and we changed some of the specifics to make it work with our Hackaday badge. And this defines here, you can see how we're going to then load the bit stream onto the FPGA. We use a utility called DFU util. And then for our badge, we're very simple. We only have serial. So other boards, if you look in this file, you'll see some of them have Ethernet, some of them have PCI Express. So you can have a lot more if your board has more peripherals. We unfortunately only had serial on this one. So I think another way to illustrate the nice object-oriented nature of this and why it's easy to make it, to extend it to new hardware or new badges, is we had a SDRAM chip on this board, the one that Jacob put on the expansion board. And that was not already in the light DRAM module. So this is the DRAM controller that we are using for our project. So the only code we had to use was just extending the SDRAM module class and then just adding in the specific timing information and structure for our chip. So we can just go pull up the data sheet for this chip, look in the table to see what the different timing information is, and just plug that in there. So rather than having to write our own DRAM controller in Verilog or something like that, we can just take like DRAM and just extend it and just put in the information that's specific to our hardware that we have on our badge. However, we did get Linux booting and running, but it was taking 300 seconds, which is not fun, way too long, right? So this was a pretty neat like open source moment, I thought. So I opened up a GitHub issue and I said, hey, you know, it's taking a really long time to boot. It's taking like 300 seconds. And Enjoy Digital is their username. Name is Florent. He's the person that created LightX. He, within like an hour or something, gave me a patch that made it run 10 times faster. And if you've not used this utility before, ASCII Cinema is a really fun thing that allows you to record your screen so other people can play it back. So when I created the GitHub issue, I showed them, well, what does it look like when it boots up in the terminal? And then I can also put it up there for other people to see. So that's kind of a neat trick if you've not seen ASCII Cinema before. And I won't play this here, but this shows what it looks like to boot up Linux on the badge. And then we, yeah, so I was saying it sped it up by 10 seconds. And then here's a look at the GitHub issue that I opened up. And to give you a little bit more sense of the Python code involved in LightX, here's an example of how Florent was able to make it go a lot faster. So one of the issues with this badge was we were using an 8-bit wide DRAM, which means that it can only grab 8 bits at a time, which is not super efficient. Normally you'd have like DDR memory that would be like 16-bit wide. So one of the reasons this was going so slow, it was accessing memory very frequently. So every 8 bits, every byte, it would have to go and access that from memory. So one of the optimizations was Florent, Enjoy Digital. He made the L2 cache wider so it could fit more in there. There were some other things that he did as well, but I think this is kind of a neat thing here. For one, if this was Verilog and I looked at the diff, I don't know if I'd be able to make sense of it. I'm not very experienced with Verilog. With the Python code, you know, even though I don't know too much about the implementation details of this DRAM controller, I can look at this diff and kind of make a bit of sense of it. So I think that's kind of a nice aspect of MeGen, which is that Python-based language, and LightX, which is built upon MeGen. I think makes it a little bit more accessible to people from a software background. And then you'll notice we have an LCD on the Hackaday badge, and it took us a long time to get it working, but Greg Davil, who's an awesome hardware hacker in Australia, who was also at the Super Conference about maybe a month ago, he finally got it working with the screen. So he used another piece of LightX called Light Video to basically create a VGA terminal with the screen, so we can see Linux booting up on there now. And I don't think you can see me myself, but I also have the badge here with me, and it's doing the same little movie there that you can watch on Twitter if you go to that URL. So this is the Hackaday badge. It had the ECP5 FPGA in it. It is also open source hardware, so you can get the schematics and the board layout and the bill of materials. However, if you wanted one, you'd have to build your own because it was only made for the people at the conference, or find someone that went who's willing to give you their badge. But that's not really a sustainable thing. So what are some open source boards that you can either build or get that can run Linux? So David Shaw's the person that originally did the open source tool chain for the ECP5 called Project Trellis. And he created this like mega board that has like super cool things like gigabit Ethernet and PCI Express and several gigabytes of DDR memory. This is not a board that you can buy, but the plans are out there to make it. It's probably not super practical, but if you wanted like the highest end board, this would be the one that you would want to build. However, if you don't want to like build hardware because it's usually pretty expensive to buy things in low quantity, there are two options now. So Greg, who I mentioned before, he has this really cool board called the Orange Crab, and it's in this small form factor called the Adafruit Feather form factor, which is quite popular from like the maker world that's working with microcontrollers. And you can get a lot of expansion boards called Feather Wings that you can add on to this form factor. So this is has an ECP5 FPGA. It also has 120 megabits of DDR memory, which means it's much more than what we have in this Hackaday badge, and it's also much faster. So this is a great platform for running Linux on LiteX VexRISC. So if you wanted to run Linux on a RISC-V soft core in an FPGA, this is a really good way of doing that. Greg just started a campaign on group gets. So if you want to get one, you can go to that group gets URL and sign up there to buy one. And it also does run Linux. We were at the Chaos Computer Congress back in December, and someone was like, hey, it'd be cool if Linux ran on it. And Greg, within a couple hours working with Tim, was able to get Linux to boot up on it. So it's a great platform if you're looking to run Linux on an FPGA with RISC-V. The other great board is from a hackerspace in Croatia called Radiona. So they have this board also with the ECP5 FPGA, and they have a couple different versions with different features. You can also see there on the board it has a lot of additional peripherals, so looks like it'd be something good, especially for doing workshops and things like that. Now, this is not something that'll run Linux, but if you just wanted to get into learning FPGAs, the FOMU board, which is a project from Tim Ansel and Sean Cross, who were also on Team Linux on Badge at the Hackaday conference, they created this small board that fits inside your USB port. The idea here is it teaches you the basics of FPGAs, and it teaches you in the context of MicroPython, Verilog, and then also with LiteX. So kind of takes you through these different environments, showing you how to blink an LED in each of those different environments. So this is a great board to get if you want to get started, and then you can always have your FPGA with you wherever you go. It won't run Linux, but it'll get you up to speed, because in some ways it's a little bit better to learn the basics of FPGAs with something simpler before you jump into the world of running Linux on a full RISC-V processor. The slides for this talk with all the links are at that URL there on GitHub. I also gave a talk back at Chaos Communications Congress that goes into kind of some other ARM-based open source hardware boards that run Linux, so that might also be of interest. And I'm PDP7 on Twitter, and that's my email address, and I'd be happy to take any questions.
Wow, thanks. That was quite a deep dive. Thank you very much for that. So we do have some questions. Let's see. So the first one is, do I remember correctly that your hardware has been in space?
Maybe they're referring to the BeagleBone. I'm not sure. I don't know if there's any RISC-V in space. I'm sure there will be. It's just a matter of time. There's probably also, I would imagine, some CubeSats with RISC-V microcontrollers. So I'm not sure about that. If they were talking about the BeagleBone, which is a little open hardware board I'm involved with, there are BeagleBones in space that have been deployed on CubeSats.
Okay. Then the second one is, when working with FPGAs, are there specific licenses, or do you use GPL, LGPL? How does this translate into soft hardware?
So one of the things that I thought was interesting that when I was at FOSDEM, I hung out in like the RISC-V room and the EDA room. And one of the things I learned is in this world of chip design, permissive licenses are much more popular. So when I was talking about those open source implementations of RISC-V, like Rocket and Boom from Berkeley, and the Risky and Ariane from ETH Zurich, those are all permissively licensed. And I believe in the chip industry, it's quite common for if there's going to be open IP that they want it to be permissively licensed. There are also some people in the chip design world that believe more strongly in reciprocal licenses like GPL, though there are not, I don't think there's really any projects right now that are, there's not too many projects right now that are using reciprocal licenses. So I would say in the open source chip design world, permissive licenses seem to be much more popular. With FPGAs, the software typically was proprietary. This like from Altera or now Intel in Xilinx. They also would offer different cores that you could use, and those would have different licenses, essentially like proprietary implementations that you could use on their chips. But a lot of this is being replaced with the free software tool chains I was talking about, and then also projects that are doing open source implementation. So like LightX is open source, permissively licensed, so is MeGen. So, and hopefully with things like Libre cores from Fossy, we'll start to see a more broader ecosystem of open source IP. By the way, if you look at chip design, people say IP all the time. IP is not IP address, it's for intellectual property, which is also kind of weird thing to say. What they really mean when they say IP is they mean like a block or a module in a design. So like the Ethernet controller, the DRAM controller would be, you know, your Ethernet IP. I also heard someone say, basically, hardware designers were saying IP, would they surely be saying library?
Okay. Then the next question. When developing RISC-V, do you need to use any proprietary software?
It depends on your workflow. So with chip design, so implementing the RISC-V is an instruction set specification. So implement that instruction set. Typically, you'd be using a proprietary flow. So you know, only recently is there kind of some alternatives to designing, doing chip design with open source flows. So typically you'd be using software from companies like Cadence or Mentor or Synopsys to do the synthesis, to do the place and route for making chips. There are now from some academic projects, one is called Open Roads, which has DARPA funding, and it's with the University of Washington, I think, and also University of California, San Diego. Essentially, they're trying to create this flow where it's completely open source, but almost everything currently being done is with proprietary tools.
I see. Okay, the next question is, do you know about the European Processor Initiative, EPI?
Yeah, I learned of that from watching some of these videos at the RISC-V Foundation events and also the FOSSI events. So this is a really neat thing that's being led by the EU, which is basically providing funding for open source processor design projects. So universities like ETH Zurich are involved in this, and several different companies as well. So I think this is exciting, and there's also initiatives like this in other countries as well. India has one called the Shatkey project as well. So it's really cool to see things like the EU and other countries getting involved in trying to generate open source chip design.
Yeah, I agree. Okay, and then we have the last question here. In your opinion, what is stopping RISC-V from becoming mainstream yet?
I think it's partly it's just it takes time. It's only kind of jumped out into industry in the last couple of years. So it was something that was an academic project for a long time. And now it's being embraced by companies like Western Digital and NVIDIA. and they're in the process of doing product design based on it. But I think it'll take a little while before we see it kind of in everything. Now, places where it seems to be quite popular right now are people that are doing microcontrollers, and also people that are doing like kind of higher end things like supercomputers and stuff like that. I've been seeing some research in that. I think the kind of thing we're missing right now is somewhere in the middle, like these system on chips that would go into a smartphone or a single board computer. And I think it's just going to take time. One of the reasons being is with FPGAs, there's not this huge risk. You can just design a system and load it onto FPGA. But when designing chips, being able to verify your design and make sure that's going to work. So to get a chip made, you have to get these masks made up for lithography, and they're very expensive. So when they say tape out a chip, they're talking about doing these masks and sending them to the fab. And that's very expensive. And if you get it wrong, you have to do it all over again. You lose millions of dollars. For these newer processes, like 10 nanometers, these super high-end Intel chips and ARM chips, it can be like tens of millions of dollars for the mask set. So one of the things that's kind of holding back some of these open source implementations, we need ways to verify that things work before they go to fab. And one of the groups that specifically is focusing on this is the OpenHW group. And they're the ones that are looking to have this RISC-V SoC at the end of this year. If you check out OpenHW Group, they have a lot of information about how they're trying to leverage things like Google Cloud to do design verification. So I would say the biggest thing that's holding back open source chip design from being out there in the wild more so is the ability to verify the open source designs before you go to fab with them. And I think it also just takes time. The cool thing is the software ecosystem is there. Like there's good support in Linux now. There's support in GCC and in Clang. So we can do a lot with QEMU. We can do a lot with FPGAs, and then essentially having chips that are available in volume in the market is just going to take a little bit of time. But by the time we get a chip to do like a single board computer with, the software support's already there. So you can boot up Debian, you can boot up Fedora right now. So it's just going to take a little bit more time, I think, probably a couple of years before we have more powerful, more widely available chips that are implementing RISC-V.
Great. We're running almost out of time, but we have two more quick questions. So has writing with MyGen any downsides as opposed to pure Verilog?
It could just, I would say, depends a lot on the people you're working with. So system Verilog is something that's quite popular in industry. So I would say one downside to using MyGen might be, well, if you're working with other hardware designers, they're probably familiar with Verilog or system Verilog. So that's one consideration. Though I think the cool thing about MyGen is it's going to allow us to turn more software engineers into hardware designers. So I think that's one of the upsides to it. So the downside to MyGen is it's kind of a new thing. Most hardware designers are using Verilog or VHDL or system Verilog. So that's kind of the trade-off there. But the cool thing here is we could turn more software engineers into chip designers with something like MyGen.
I see. Okay. And the last one, looking at your crystal ball, when will be using RISC-V in our desktop PCs?
Yeah, I think that's a tough one, and that goes back to what I was talking about with making chips. Is our desktop PCs are using really high-end technology, so really small, 18 nanometer, 10 nanometer, and to produce masks for these processes is super expensive. So it really takes a company to invest a lot of time and money into the verification and also like the market justification. So I think it'll come eventually, but it's going to take a while before we see companies producing, something like a Core i7 with RISC-V, because it's a really large bet for them. Like that mass would probably be tens of millions of dollars. So it's a pretty large bet for a company to make. Like we've seen with ARM, in the server market, it's taking a long time for that to happen. But I think it will happen, and I think in countries like China, there's a huge motivation to move away from proprietary instruction sets like Intel and ARM and to have more control over their own technology. So I think it'll come, but it'll probably take some time. Maybe FOSS 2025, foss-north 2025. Maybe we'll have a RISC-V laptop or something.
Okay, great. And then not a question, but Anonymous wrote, "Thanks for the great talk. This was one of the most interesting so far." And I agree. Thank you very much. And I give back to Johan.
All right, thank you.
Yeah, thank you all. It's time for our lunch break, so we will be back at 2. See you all then.
Welcome to foss-north, the virtual edition. We would like to thank all our sponsors and partners in this difficult situation. Our gold sponsors, Luxoft and Ansible by Red Hat. Our silver sponsors, ITRS Group and Make It Right. Our base sponsors, our partner projects, the open source community and the region of Gothenburg. And a huge thanks to our awesome community. This would not have been possible without you.
Welcome back, everyone. So next up is Bolaji, who will talk about effective documentation and why that is important in open source project. So the stage is yours. Welcome.
Thank you so much, Johan. Hello, everyone. My name is Bolaji Deji, and today I'll be talking about effective documentation, the key to open source growth. So just so you can follow me, you can just scan this QR code to put the link to the slide already, and then you can just roll along. So I guess you can see this, you just scan quickly, let's roll. So yeah, a little bit introduction about me. So I work at a company called Hashnode as developer evangelist and outreach. So basically, my role revolves around making my company happy and making developers using our products happy. So you can call me a happiness engineer. I ensure my company is happy and developers using our products are happy. So yeah, I'm a front-end developer and technical writer. Yeah, I'm also community manager at Open Source Community Africa. It's a community of open source enthusiasts in Nigeria, and also an accessibility Jamstack, docs, and free and open source Africa advocates. So that's pretty much about it about me. Okay, so just a quick introduction to what we'll be rolling through today. So first of all, we'll run along through introduction to open source documentation, the needs of open source, understanding user personas, the effective documentation strategies, bad documentation checklist, good documentation checklist, and some documentation tools I would recommend you should try out. And yeah, what next? So so basically, in open source, documentation is the information that describes the project to its users and contributors. So there's an emphasis here on users and contributors. So your documentation serves two purposes. There is documentation for your users, and there is the one for your contributors. So we're talking about open source here, and I'm sure you're familiar with what contributors would mean and what users would mean. So this is basically a quick introduction to what documentation is in general. So before we proceed, there are some myths in open source I would want to outline now. I'm sure we might be familiar with that. And one of those myths is open source is the responsibility of the creator alone. So like this is everywhere where people feel open source is just about the creator. There's this tweet from Angie Jones like a couple of weeks ago, and she said someone asked me if its tool was open source, and I excitedly said yes, and began to tell them how they could contribute. They looked puzzled and they didn't actually care if it was open source. What it meant was it is free. And funny how everyone wants free but don't want to help build it. So like there's several engineers and developers using open source projects. They just believe it's free and open source project, but they don't really want to contribute to it. And that's in it. Open source is just not about the creator alone. It's open source. So we'll get to that. And secondly, there's a myth that open source is just about code. And this is really, really false because open source is not just about code. It encompasses all the planning that goes before writing the code. You don't just sit and then just say, I want to build an open source project from nothing. You have to do some planning and, oh, I have this idea and then I want to put it down to something. So there's a process that goes even before writing the code itself. And there's a process that goes while writing the code and a process after writing the code. So open source is not just about code. We have design, there is documentation, there is so much more that goes into open source, even marketing and funding, so much more. So yeah, open source is not just about code. And so yeah, so today we are talking about effective documentation and how it is a key to the growth of your open source project. So we're going to be doing something like the first one is understanding user personas. Like one key to building great open source documentation is understanding who you're writing this documentation for, because this varies across different projects. I might have an open source project, like a very small project, maybe a library or just a package, something small. I understand that my persona is just maybe developers, just wanted to try something out or something. Like my audience is just very little, and you might have a very complex project, like let's say a storybook, and then your audience is very much larger than just developers. So the first thing to building effective documentation is understanding your user persona. And I outlined a couple of personas we're going to look around today. And the first one is end users. So who are end users? The final consumers, people using your project. And one thing you should know that an end user doesn't have to be a developer. So you might be building an open source project that is eventually going to be used by just random humans who are actually not developers. Okay, let's say, I don't know if you're familiar with Sugar or music blocks from Sugar Labs. So it's an open source project, but it's being used by kids. So those kids are not developers, but like they're the end users. So if you're writing a documentation, you need to also understand that, oh, I'm going to have an end user at the end of my project. So you should consider them also while preparing for your documentation. The next one we have is developers. Like I'm sure this is the one we eventually think we are writing our documentation for. We focused a lot on writing for developers, and this come when you're thinking about having contributors. So in every open source project, you have contributors, and then you're writing your documentation for developers, and this can cut across different range of developers, beginners, intermediates, and all that. I'll explain more around that in a couple of next slides. Designers. So this differs around several projects. So your project will determine if your user persona will include designers. Like I said earlier, these personas I'm listing differ for projects. I'm giving you a general list so you can look at it and say, okay, which of these personas apply to my project? For a small project, you might not be writing documentation for designers. If your project have some sort of design contribution, then you should also write some documentation for designers. How do they set up the project on either Figma or Adobe? Like, how do they contribute and all that? So you need to consider them also. So next we have technical writers. People most time wonder and say, how can technical writers contribute to open source? And I'm like, what? um, documentation itself is open sourced, and then it's been managed by some people, and those people are going to be writing, and obviously you would need technical writers to also contribute to your project. So you also need to understand that you would have technical writers. How do you create your projects that it is welcoming to them? Okay, let's imagine your documentation is written in Markdown. So what guide do you have for technical writers to understand how to contribute to your open source project? Because I might not be familiar with working with Markdown. Possibly I am just familiar with writing normal text and I don't know about Markdown. So the documentation has to be welcoming for me to understand, oh, it's Markdown. This is how Markdown works. And it should be so much beginner friendly. We'll roll across that in a couple of next slides to come. So program managers. So where do program managers fit in your project? The role of a program manager is obviously just managing a project and making sure everything runs from start to finish. So as the program manager, I am looking for tools that would make my engineering team scale. I'm looking for tools and products that would increase like our workflow, right? So when I'm scanning through for some projects, I'm like, oh, how can we simplify this? How can we automate this stuff? And then I just, oh, let me just make a research for a quick library that can just help us automate one or two things. And then I find the projects. As a product manager, I am a user, and then I have my own reasons of coming to your project. I would explain more around these users and what they want while coming to your project. So you need to understand that program managers are also coming to your project. And next, we have financial contributors. We have like an awesome and amazing community in the developer ecosystem right now, whereby we are all supporting each other in terms of learning, in terms of open source, and so much more. So we have so many companies, so many individuals who are supporting open source projects financially. So we have some financial contributors who are looking out for successful and thriving projects to sponsor. And so how do you create your project in a sense that is welcoming for financial contributors? Is one thing we would also look around because they are also one persona. And yeah, that's pretty much it. So, and this is the interesting part now. So what do these user personas want? What do they actually want while coming to your project? You need to understand, first of all, what do they want to get out of your project? Um, what solutions does your project offer to them? What could be your initial visit mindset? And okay, so let's roll to the 3 points. So the first one is, what do they want to get out of the project? I mentioned for an end user just wants to use your project. I don't really care about what technologies you used to build. I don't really care about installing your code base. I just want to see the finished work. So the documentation at that point is explaining how to use a project. How do I use this? How do I use that? And that's all that matters to an end user. To a developer, you're explaining how to set up the code base, how to install this, how to run this, how to set up this, and all that. So your documentation to a developer is quite different from an end user. And then just so we go back to the user personas. And for designers, it's quite different. I mean, a designer doesn't really care about your code base. They just need to understand the design parts of your project that needs contribution. How do I set up either Figma or like what tool are you using? How do I contribute to your designs? How do you use GitHub and all that? That's all what you're writing for a designer. For a technical writer, you're explaining what pertains to them. A technical writer just cares about whether or not your project uses Markdown and all that. How do they contribute to the technical part of the project? And program managers just want to see um, how thriving your project is. So as a program manager, I'm looking for a tool or library that would automate stuff or a workflow for my company, and then I just search in GitHub some trending topics and just search for this social library, and then I find yours. So I'm scrolling through your project trying to see if it's worth trying out to my company. So my goal at that point is not to really try your project out, but I don't want to try out several projects. I want to understand that your project is worth it for me to try. So you need enough information to tell me and convince me that, oh, this project is this and this is what it does. So in the next couple of slides, I'll explain what you can do around that. And then for financial contributors, we all know that they don't really want to know how your project is built. They want to understand the history behind that project and what exactly you're doing with your project and how thriving has it become. Like I said, now what statistics do you have? What have you achieved so far? And they need to understand that, wow, this project is doing well enough. Like we need to sponsor them because the creators are spending their time, their money, their energy, and all this. Let's sponsor them. And then just want to see all that information. So what you put out for an end user is different from what you put out for a financial contributor. They all want to see records and statistics around your project and all that. And so you need to put in mind that they want to see, you need to understand what they want to get out of your project. That's the first mindset they come with. And then what solution does your project offer? Is your project a library? Does it help people to automate something? Does it help people to do this and all that? You need to understand that first of all. And then you need to understand what could be the initial mindset. Like I mentioned, each user persona comes with different mindsets to your project. And the next thing you need to understand is where are these user personas coming from? Like, how did they find your project? Now, like I mentioned earlier, all these plans you make before writing your documentation, you need to understand this so you can make sure you have an effective documentation. So understand where your users are coming from. So first of all, are they coming from search engines? So for me to come to your open source project from the search engine, it obviously mean I have a mindset. So I did not just go to Google and just search, let's say, Storybook and open source, blah, blah, blah. And I didn't just randomly just type random words and just stumble on your project, even though that can happen. So I obviously went to Google to search for your project for a reason. It's possible I'm looking for what tool can I use to build some UI components in isolation? And then I just found Storybook. Like, so there was a query that brought me to your project. So understanding where the users are coming from. The first one is from search engine. And second, it can be from social media. This is very, very common. So when a creator builds an open source project, they usually maybe tweet it and say, oh, I did this stuff, or they post it on Reddit or other social media platforms, or they post it on Hashnode and say, oh, I do this cool stuff. And then I just check it out and say, oh, nice. So I can just stumble on the project on my timeline and just click on it. And then at that point, I don't have any mindset sort of. I'm just clicking to try and figure out what's up with the project. So notice the difference between search engine. For a search engine, there was a query. I was trying to find something and then I stumbled on your project. From social media, I was just scrolling through my timeline. And let's say someone I know retweets that tweet, and I'm like, oh, cool. Let me check it out. I just click on it and I just what's this and what's all that. I just scroll through. So at that point, I really don't have any mindset. But funny enough, your project might be something interesting that I would want to try out. And then by scrolling, I might just say, oh my God, where has this project been all along? I've been looking for this. And then I just try it out. So understand, next we have social media. And then next we have backlinks from other sites. So this is very common. Basically, a backlink is just a link that's a link from one site to another site. So let's assume I built an open source project called X, right? So and then in another website, let's assume an article or something. I can reference that article in the sense of saying, oh, have you seen this open source project? It can help you do this and that and that. And then it's listed in an article. Let's assume I'm reading that article and then I get to the point where that link is inserted there. I just click on it. My mindset is quite similar to the person coming from social media. I just stumbled on it and notice the difference between social media and backlinks, because for you to click on that link, it means you've read all through the article and that link it's sort of related to what you're reading about. So when I check through and I see, okay, this is quite similar, and I just click on it and then I just move straight to the project. I have like half mindset around what I'm looking for. I'm looking for something which something related to the article I was reading, and then I just check out the product. So that's the third location from where your users are coming from. Next is we have package managers. So we have tons of open source projects around packages, JavaScript or Python and other languages. So with this, we have NPM. So like NPM is a package manager that holds all JavaScript packages. So a very common way for me to stumble on your project if it's a package is by searching on package managers. Let's say I just want to find a new package that can help me automate something. I just go to NPM and just search about that, and then I find it. So this is quite similar to search engine, but it's quite detailed. I understand that I am looking for a package. I'm not just looking for any random open source project. So I go to a package manager to find a package. So my mindset there is to search with a particular query, just like search engines, but for packages. So these are four ideas around where your users might be coming from. So next you need to understand is how much time you really dedicate to your documentation. And this is very crucial in helping you prepare for an effective documentation, because when you look at it, an end user doesn't really have so much time. Like, it's possible someone recommends that product to me. Let's say Music Blocks, for example, which is a tool for kids. So I'm a kid, I really don't know anything about your project. Someone recommends, oh, I've just seen this product out. Like, I'm not a developer, I just check it out and I'm like, oh, cool, awesome. All I care at that point is just using your project. So any documentation you should prepare for me at that point should be as little as possible, because I really don't have so much time to read so much documentation. I just care about your product. So if you're preparing the documentation, maybe any notification tooltip and all that kind of stuff, it should be very brief. Just show them, okay, when you join. And a very common factor among this kind of project is products that have end results, like an open source project like a music block, like it's an open source project, but like there's an end result that people use. Like an open source project like Storybook, it's more like for developers. So we like use it on our own personal projects, right? It's not really consumed by end users, right? So while I'm coming to your project, I really don't care about how you build your project. I just want to use your project. So whatever documentation you're preparing for me at that point should either be inside the application itself or like before I start using your application. You don't have to redirect me to a page to read the documentation before I come and download your application or and all that. So next is how fast do they want it? And end user wants the documentation as fast as possible. For a developer, they want it as fast as possible also, but like it doesn't mean you should increase the speed of how they should read it. Like a developer wants enough information about how to set up their project, right? So while considering the speed at which you want them to read your documentation, you should also consider you need to provide enough information. So this speed varies across the length of the information you're providing. So if your documentation is, if your project is easy to set up, you really should calculate how long does it take for me to set up this project and how can I optimize that? So it would differ by project. So you won't say because this project took me 3 minutes to understand how to set up, and then yours should take 3 minutes also. Yours might have a longer setup, and then it might take you like, let's say 5 minutes. That's fine. So understanding your project is one first key. You need to understand your project and how it works, and then you can now determine how fast they want it. For like financial contributors, how fast do they want to read your docs? If financial contributor doesn't really care about how to set up, what text you're using. They really don't care. They only care about, okay, what does this project do? What made you build it? What have you done so far? How thriving is your community and all that. And then they just want to see those statistics, and then that's all. I just decide, oh, I click on your Patreon link or your Open Collective link and I sponsor you. So you understand that a financial contributor doesn't really have enough time to read so much about all your documentation. And then next is how fast can you have them? So this thing is like it's more like a personal analysis you do before writing your documentation. Now you understand that your users want your documentation in like 3 minutes. Now you understand that. So how fast can your documentation serve them? It's one thing to optimize your documentation for your users. It's another thing to ensure that your documentation serve them. Because for let's say a developer, right? what I want to get at the end of your project is two things. It's either I am trying to contribute to your project or I'm trying to use your project for my own personal project. So I'm either trying to install your project to mine or trying to set up your code base so I can contribute, right? So I have two mindsets there. And what you're trying to serve me now is provide information on how I can install your code base or install the finished product. So that's two things you're trying to serve me. So now you understand how fast I want to get this thing because you understand that I just want to set up, right? And then you now understand how fast can my documentation serve them. So this can also work if you already have some sort of documentation set. So you need to like reiterate and understand how fast is my documentation serving my users or my developers. And the great way for you to understand this is by running some sort of survey. You can do some documentation survey, understand, okay, get some developers who are active or who have been using your projects for like a year or a few months. Ask them, how fast did this documentation help you? You can even get people who are not. You can get these user personas, each of them, and ask them to like run tests on your documentation. You can get an end user, you can get a developer, you can get a program manager, a financial contributor to try out your documentation and give you feedback on what they feel you can improve. So like you don't tell them, oh, I want to check if X or Y. You just tell them, go through this documentation, tell me what you think. How did it serve you? You have the questions already. How fast? How fast was it able to answer your questions? Stuff like that. You need to be able to run some analysis and survey before starting out documentation. And this is what many people fail to do. We just open some README file, just type down some stuff, blah, 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 and we're done. And then we just ship it out. And then you never can tell if it is actually serving your users or not, but you just believe you have some sort of documentation. And I think there's a difference between good documentation and documentation. And that's why I titled this stuff effective documentation. You might have a documentation, but it is not effective enough. So how do you know if it's effective enough is what we're discussing right now. So a first thing you need to consider also is how fast can your documentation respond to your user issues. So one thing you should understand in this sense now is when it comes to contributing to the project or using projects, there are times where your project will have issues. People have feedback to give back to you. How fast can your doc respond to their issues? Okay, if you use GitHub, there is an issue system that people use to report issues, bugs, and all that, right? How fast can you respond to them is also being it's liable to your documentation. So when I come to your docs, I've seen projects whereby someone creates an issue for a bug or so, and then there's no feedback for like 3 months, 6 months. Like that's pretty not cool. And I should get enough information on your documentation on how soon you can respond to me. I've seen docs that it tells you, oh, if you have any issue, you either open an issue, we'll get back to you like in some days and all that. Like your user should understand how soon you can respond to their issues because this is also part of one reason why they might be coming to documentation. Because for example, let's assume I found your project from a package manager like NPM. I possibly might not have stumbled on your exact code base, right? So I just installed from there. And at some point, I have some issues with your project. I want to get help. At that point, my mindset for coming to your open source product is just to get help, not really to install anymore because I've passed through that stage already. I just come to, oh, I need help. So your documentation should also explain how and where I can get help. Do I need to reach out to you via email or just create an issue? Or how long will it take you to respond to me, even if it's just an estimated time of response? Or if I have more questions, do you have some sort of community? Do you have some sort of Discord channel or Discord server or Slack? Like whatever, all the social media spaces I can reach out to you for more help. Like it should be included in your documentation because that is one mindset people can come with. And then lastly, you need to consider how satisfied will they be. And like I mentioned earlier, you have to find this through a survey. You need to understand how satisfied your users have been so far. You analyze for both end users, developers, program managers, financial contributors, and all the user personas you can come across for your project. Understand how satisfied they have been over time. And then one other thing you need to understand while preparing for documentation is how technically savvy your users. Now, in terms of users and contributors, you need to understand that first of all, there is a category called newbie, and then there's a category called beginners. It's quite totally different. So for a newbie, I have no idea about your project or what it does. So let's say any open source product relating to Android, I really don't know much about Android, right? So if I stumble on your project, I am a newbie. I really don't know anything about that product. And then you have to explain the bits and pieces of each. Like from the start, you need to explain how and how your project come across, what does it do, and all that. That's for a newbie. Now, a beginner is slightly different from a newbie in the sense that I am not really a beginner to tech, but like I'm a beginner to your project in the sense like let's say I'm fluent in JavaScript, right? And then I have little idea about what Ruby does, right? Or Ruby on Rails. So me coming to your project, I am no longer a newbie, but like I am a beginner to your project because I really have no idea about the technology you're using. But like I might want to use it at that point because let's say I'm starting out a new project with Ruby or trying to learn something around Ruby, and then I just check out a project and then I'm like, okay, all right, wow, what do I do? So at that point, I am no longer a newbie, but like I'm a beginner to your project. So there's a slight difference between a newbie and a beginner in the sense of documentation because a newbie has totally no idea about what your project does. And most times, end users fall into the category of newbies because they really don't understand anything about your project. Developers most time might fall into the categories of beginners. So understand that this is the second technical strength you might get. And then the third one is intermediate. So intermediates already have an idea of your project, right? It's possible an intermediate is already learning one tech or the other, and then I'm trying out, like let's say in the JavaScript world. So I already know React and I'm trying to learn Vue, right? Then I'm like, oh, I already have an idea of how React works, and then I'm trying to check out Vue. So I'm an intermediate, right? Because I have an idea of how the old JavaScript ecosystem work, right? And then next, we have experts. So it's very easy to. Why you need to understand how technically savvy they are is that will help you in deciding how lengthy or how effective your documentation will be. Because for an expert, you just need to provide them with little information. Like they've been working for like years and they understand how to set up and do all that stuff. You just tell them, this is it. You really don't need to tell an expert and say, oh, you need to npm. Like an expert doesn't really need to see you write npm install something. I just need the package name and I just install. For a beginner, I might need you to write npm for me because you might even need to reference a documentation or a link, a backlink to something that explains what npm means for me because I really have no idea. And like I mentioned, this varies across several projects, but understanding all this would help you in determining what strategies work best for your project because you would then determine, okay, is my project being used by beginners and newbies? For a project like, let's say a JavaScript framework, right? It's assumed before you use that framework, you already have an idea of JavaScript, right? So you won't assume that you have newbies in that category because it's like your project is based on something else. So it's assumed that before you can even learn this, you must have passed through that, right? So you at that point you understand that your documentation should be focused more on intermediates and experts. So all these user personas and all these strategies will help you understand which works best for your project. For a small and very little project, you might need to consider newbies and beginners. Or for like a very complex project, like something really complex, you might just consider intermediates or just experts. You never can tell. So understanding what works best for you is really, really, really great. And the last one is just those who say my code, it's a code. Those are like really, really super professionals who've been doing it for years, 20 years, 50 years. Like you can imagine, there's a slight difference between experts and this category. So you can, yeah. So now we've outlined some of these user personas and what you should consider. So the next thing you should look around now is what effective documentation strategy should you follow to ensure that your documentation is actually effective? Because from all of this so far, you can understand that it's possible your documentation is not effective at all. It's just standing there, just a README file. You never can tell that if it's helping your users or your contributors. You never can tell. So first thing you need to understand or you need to do to ensure that you have an effective strategy is first of all define the vision of your project. So now this varies across several projects. So what are the core reasons people are engaging with your project? What was the history behind you starting your project? What are you looking at the project in the next couple of years? So a project like let's say Storybook, right? I've been using Storybook before. I use them a lot. Okay, so let's say the idea behind that is to help people build UI components in isolation, right? And then what vision can you look around that? Okay, in the next 3 years, I want all front-end developers to be able to utilize my product. I want them to be able to use Storybook to do all they want to do, to build all kind of UI components they want to build in isolation with so many features and all that. Because at the point of releasing open source projects, you really don't have a finished product, right? And we can take cue from products like Code Sandbox. Like if you read the history or any story from Ives, you would see that at the point of creating Code Sandbox, it was just a small project, right? You were just trying to mimic VS Code and bringing it to the web, right? Something around that, right? So at that point of starting the project, it just had like few ideas and few features, but like he already had some really cool features in his head, and maybe you already was thinking around, okay, in the next couple of months, I want people to be able to run an entire project on Code Sandbox without having to do anything else. Maybe at the early stage, his idea was just to create an editor that works on the web. And then already had an idea, okay, in a couple of months, I can now add a feature that allows them to run a project on the web. So understand what vision you have for your project and keep that in mind. That's the first thing you need to do. And then next, you need to define your target state. So one thing you need to understand is be clear and realistic about your documentation goals. Don't try to do too much. You don't need to, because we've talked about effectiveness, and then you just want to have like a documentation of like 5,000 words or something around that. Like, no, understand your target state and be clear, be realistic. You should do what you know you can achieve. For a small package like let's say a JavaScript package or something just so little, you don't have to worry about lengthy documentation. You just type something small that is effective on its own. So being effective doesn't mean it should be bulky. It doesn't mean it should contain too many information. It just means it should contain enough information that is needed at that point based on the user persona. So be clear and realistic. Don't try to go overboard here. Understand what works best for your project and then be clear. What do you think you can achieve? So in the first month, let's say you plan on just having the documentation on a README file. That's fine. And then you already plan that in the next couple of weeks, you would have like a docs page, like something complex. Like at the point of starting your project was little, but like you already assumed and say, oh, in let's say 6 months, my project should have grown so much, and then I will have so many people using it. I need to provide enough information. That's a goal. Be clear and realistic. You would not try to now create the documentation page at the early stage when it's not really needed, but it's a goal. You understand that you will need this in the next 6 months, but be clear and realistic. Don't try to go overboard here. And then next thing is do a gap analysis between your current state and your target state. Like I mentioned earlier, it's possible you already have a documentation now. So understand what is my target state. In the next 6 months, I want my documentation to be able to serve like 1,000 users, where it contains enough information about my project and how to set up and how to use it and all that. That's a target state, right? So be clear. Do an analysis between where you are now and where you hope your documentation will get to. So analyze your current documentation and then note the differences down. What lapses can you identify? Is the documentation not getting enough views? Is it based on all the surveys you've done? Are people, the users, are they complaining that it's not serving them well enough? Are they complaining that it's too lengthy? All those surveys you've done. Now, note the differences between where the documentation is now and where you want it to be in the company based on your target state, right? So note down those differences. And then after noting all those differences, the next thing now is to tackle those differences. So you need to introduce some approaches and processes to reach this target state, because you can't just have a target state and expect that in the next 6 months you will get to that target state. You need to make some efforts or make some plans and some processes to ensure you get there. You can't just say in the next 6 months, I want X, and you're not making any plan to get X, right? So you need to introduce some processes, right? And like I mentioned earlier, these processes would vary. I already mentioned them while talking around the user personas. It varies across projects. When you understand your user personas and understand their mindset, what do they want out of the documentation? Now you have a clear understanding of what you're doing. So it's now time for you to introduce approaches. How can you improve your documentation? Do I need to do I need to add more links? Do I need to introduce something much more than text? Do I need to create a separate and unique page for documentation? Do I need to add some animations? Like based on your feedback, your surveys, based on all the analysis you've done so far now, start introducing policies that work best for your project. And we already listed so many of them down. So the next thing now is set up and execute those processes, right? So you understand what to do now, right? You've outlined some processes you want to face. So now the next thing is to set up and execute some of those processes. And one thing you should know when it comes to executing the documentation process, it start small and prioritize sustainability. So one thing people fail when it comes to open source projects is they don't consider what would happen in the next 6 months. So you have a documentation right now, like you just created the project, and then in the next 3 months, what do you think will happen to that project? What do you think will happen to the documentation? Is your documentation going to be maintained by yourself or contributors? You need to understand that while executing these processes, you're executing plans that prioritize sustainability, because you want your project to continue in the next couple of months. So it's possible while planning, you might now introduce, okay, do I want to get someone to work as the documentation maintainer on my project? Do I need to get a volunteer or so? You need to consider all that. How do I sustain my documentation? Is something you need to consider while preparing and executing these processes. What plans can you ensure with them? What plans can you put in place to ensure that your project is sustainable, right? Quality over content, like quality over quantity. Like this, I am not saying you choose quality or you choose quantity. What I'm saying now is this would vary per your project. Your project might need quantity and might not really need quality. Your project might need quality and might not really need quantity. So let's say a very popular project, right? Like I mentioned, a very complex project, right? It's assumed that you need to have passed through one stage to get to that project. Like in a total newbie cannot just come and want to, let's say, use a project that involves GraphQL, right? It's assumed that you obviously have passed through building some kind of APIs before, or like you should have an idea of how APIs work. Possibly you have worked with REST APIs before then. So like you're no longer a newbie, but you're just a beginner to GraphQL, right? So at that point, you should prioritize quantity. I'm sorry, quality, because like I don't really need too much. Like I don't need too many lines of text. Like I have an idea of what I'm coming to do. So what I want is quantity documentation. Like I hope I'm not confusing you. I can hear you, but like I hope you're following. So you need to provide quality at that point to your users. So it needs to be so qualified that they can understand what they're looking for from your product at that point. But like for a total beginner, you might need to add so much quantity of documentation, because I need to understand what the NPM is. I need to understand all the different packages you're using, like all the basic stuff you're doing. And now you might be thinking, how do I ensure that I provide documentation for each user personas? Because you might not want to have them all in one documentation. Like I mentioned, you might want a unique documentation page for your project. And then we have categories. You can have a quick start, and that quick start is useful for people that fall into developers and experts. And then you might have like a full guide. You might have like a complex guide. You might have a deep dive guide. Like you can have several guides that is like you like abstract several information into different guides. So like for beginners, they want the full guide, right? So you put all the entire information there. For developers, you can put theirs in a quick start guide that just contains how they can quickly set up. So these are the kind of things you should also consider around your documentation. And then one other thing that works best is leveraging other technique aside text-based content. This is one thing people fail to do. You need to introduce stuff like visual documentation. The documentation should not only just be around text. Like you need to understand also that the user personas have different mindset. I might not like text so much, right? And then when I come to the documentation, I am bored. And then if you now do your analysis, you understand that your docs is not serving me. It's possible to serve me at the end of the day, but it's not fast in serving me because I hate text, or I'm not so confident. I'm comfortable with reading so much text. I might get tired, like in let's say 5 minutes of reading the documentation, right? So introduce other techniques, visual documentation. You can work with animations, illustrations, videos. You can introduce use cases. So where is your product being used so far? Introduce projects that have been built using your open source product, right? Show people how your product is being used by the global ecosystem. Show them working samples. So like, okay, my product helped you to do this, help you to do that. Okay, how has it been implemented? So I have some working samples that show, okay, this is an implementation. You can just set up a sandbox, a code sandbox that shows you how to implement the entire project on something, right? And then I see working sample. And then you can also add testimonials. So like I mentioned, for like a program manager, my mindset at that point is to figure out if this project works well, like if it will work well for my company. And if I now find a fellow program manager as a testimonial on the project, I understand, oh, I know this guy, or I know this lady, right? And I'm like, oh, cool. So long he has used this project and I can try it out because I believe it worked for him and it worked for me. It's like it's help the program manager at that point to get what they want from the documentation as simple and as fast as possible. So you need to always roll back between each of the strategies we've considered today, because it rolls between your user personas, their mindset, and your strategy. So roll through those three and always iterate back and forth. So understand that each and every strategy you make is going to affect each and every user persona you have listed out for your project. And the next thing to add is metrics, like I mentioned, for financial contributors and let's say program managers. They want to see metrics, right? As a contributor, I want to support your product. I need to understand that it is worth supporting, right? And one way I can figure out that is by metrics. Show me how we have 5,000 downloads. We have several. These are the projects that have used our product, and this is all and all that. We've been around for like 1 year now, and then we have reached this, we've achieved that, and all that. So add these metrics for them, because each and every of the persona rely on different techniques. And that's why you need to do an analysis on your own self. So if you have a documentation currently now, you need to go back to your docs. If you have possibly a maintenance, have a meeting, reiterate and like reevaluate your plans again, come again and say, okay, we are starting a fresh documentation. We want to do this, we want to do that. And putting all these strategies together and then come up with something new. And like I mentioned earlier, sustainability. This is key. You need to understand that there should be a sufficient plan and community to maintain the documentation. I've had projects whereby I just try to check out the documentation and then I'm like, oh, how to do X and Y, and then I check it out and then I realize that the documentation is redundant already because let's say like last week they shipped a new feature and then it's obsolete already. So you need to understand that your documentation should scale while your project scales, because it won't serve me that way. It's possible that that documentation was serving users like 3 weeks ago, but now you've implemented a new feature and then something else needs to be implemented in another way. You need to scale your documentation while your product is scaling. So I should not come to documentation and then figure out that this doesn't work anymore. And I'm like, I have to create an issue, or I have to complain. I'm saying, oh, this is not working. And you have to tell me, it's redundant. Like, it's not cool for your users to figure out and find out that your documentation is obsolete. Ensure that you have a sufficient plan to maintain the documentation. And you can do this in several ways. You might have a small community of technical writers that can volunteer to help you. You can have bounty programs, like if it's a very, very huge project, then where you call for technical writers to help you improve your documentation. There's several programs around that now. I'll explain some at the end of my talk. And then you can have all that and then make plans. So what developers mostly do now, I just build up stuff, I build the project, and then I just open source, and then that's all. I just write my documentation myself, and I'm like, that's all, right? But you need to understand that you need to make plans also for your documentation. You need to understand, okay, I need a volunteer documentation maintainer. It might be a friend, it might be anyone. Like having these plans down will ensure that your project will be successful and sustainable. And then also one thing you should understand is build a community around the documentation. I've said several stuff around this now. Attract collaborators, sell your vision, recruit help, and simplify your contribution process so like you can have a community around the documentation. One project I love so much is Open Collective. Like the documentation community is really, really awesome. Like it's just like an entire department on its own. It's like it's not all about engineering and writing of code. Like create a small community of documentation experts, beginners in your project, and then have them brainstorm together, fix issues for you, and all that. Like in the long run, you find out that you're sustaining your project. Okay. Yeah. Automation and track version issue. Like this is very important because in analysis, you need to understand where your project was in the last week and where it is now. Like I mentioned, understand your target state and your current state. So one way to understand this also is by tracking your history, like versioning your project, your documentation. You need to be able to go back and see what your documentation looks like 3 years ago and understand, okay, this is where we were before, and this is where we are, and this is where we can be in the next 3 years. So ensure you're automating stuff and you're tracking your changes. And so quickly, let's run to some checklists. So how do you know if your documentation is bad? Very simple, right? First of all, if your documentation doesn't scale with your project, it's bad. I mentioned this already. Ensure that your documentation scales with your project. And next, if your documentation repeats stuff, like you should not be repeating. If you're repeating, ensure you are categorizing them. Like I mentioned, you can have quick start guide, full guide, deep dive guide, like different guides for different personas, right? But I should not be saying the guide for full guide in the quick start guide, right? Like you should not really make it complex by including different patterns at different points. Ensure you don't repeat stuff, right? Ensure you are categorizing when it comes to repetition, right? And then next is if your documentation is so ambiguous, like it's bad. Like I just come to the documentation, I'm like, what? Oh my god! Like just so ambiguous, like it would really, really not be cool. And next, if your documentation is not inclusive enough, like it's not good, it's bad. Like I mentioned with newbies and beginners, you need to understand that a newbie has totally no idea of your project. So you should ensure that you have some sort of guide for them to understand how your project works. And recently I was working on some documentation for a project and I literally defined like every single stack I used in it. And I was like, oh, React does this, Storybook does this does that. Like I literally defined all of them and added external links. So I could categorize that, right? And then a newbie can easily go there and understand that, oh, this is it. You need to understand that documentation takes time. As much as you're putting time into engineering, you should put enough time also into documentation. It's not just about writing README files. It's like an entire job on its own. You need to put in enough focus. The same focus you put into engineering, the same focus you put into documentation because it takes the same level of time. Like all this planning we've mentioned so far, you can see how complex it can be, right? And then if it's missing contribution guides, is bad. If it doesn't include support links, how can I reach out to you for help or reach out to your community for help? It's bad. If it doesn't respond to user issues in time and there is no estimated time of response, it's bad. I should not create an issue and in the next 1 year I've not received a response. I understand it takes time and the process around this, but like ensuring that your users are aware of your availability at every point is very crucial. So let's assume like in times like this, due to the pandemic around the world, and then let's say you're spending some time with your family, you don't have enough time. In your docs, you can add, I'll be unavailable at this point. I'll be available around 14:00 to like 17:00. If you have any issues, ensure you ask. I'll check them during this time frame. So the users already come and say, okay, it's not available now. We'll be back by this time. So I can really just sit back and say by 14:00, I'll receive a response. And I'm cool with that, right? Yeah, that's all around bad documentation. So if your documentation doesn't satisfy, like if your documentation has all this, it's bad, really, really bad. So how do you know if the documentation is good? The first thing is if the documentation is good, if it can answer all these questions. The first question is, why was this project created? What problems does it solve? How can I get started with it? Where has this project been used? Who are using the project? Some live use cases, analysis of working samples, right? And then how can I contribute to your project? If you can answer these questions, right? It's good to go. It's a good documentation. So you need to ensure that your documentation can answer all these questions. Once you can do that, like you're good to go. And then I'll recommend some documentation tools you can use for your project. You can check out some I don't know. It can vary per your project. You might be using Markdown or so. There are several tools like Gitbook. There are several tools around you can run around for documentation. And you can use GitHub also. You can use any kind of tool you want. And one important tool I usually recommend is All Contributors Bot. So it's a kind of automation bot that ensures to welcome and include all your contributors. And most time people forget to add people who contribute to documentation. You just say you just add the code contributors or the financial contributors. Like all contributors bots ensure that every kind of contribution is welcome. So you can check it out at just Google all contributors. I'll provide a link to my slide later on so you can check it out. So what next now? What you do now is define a documentation vision for your project and prepare some goals, because I don't know how much complex your documentation is, but like sit down and define a vision for your project and prepare some goals, and then build a community around the documentation and ensure that you prioritize sustainability at the early stage of the project. So once you do this, you're good to go. So like I mentioned, there's some programs around I would recommend that you check out, like Google Season of Docs. It's like a program that ensures students and all can help contribute to the documentation of a project. So if you have a project and then you need help with documentation, you can apply. I think there's a session going on for this year, and then you can Google will support you by bringing in students to work on your documentation. You can check it out. And if you're a user or a contributor, you can check it out also. And the Good Docs project is a project currently ongoing to create some kind of templates and like guides that you can use to ensure your documentation is effective. So like I'm sure you might be wondering, all this thing is complex. How can I easily get started? So the Good Docs project is working on some kind of templates and like quick stuff. You can easily just walk around and just say, oh, some starters, and then just walk around. And then this is a logo for the all contributors bots I mentioned earlier. And yeah, so the documentation should provide users with a roadmap to using your project. Cool, right? So documentation helps your users to succeed with your software, and it empowers them to be self-sufficient. It enables them to give you further feedback, and it is the organizational backbone of your project, because the user feedback they give is what will help you to improve your project, right? So ensure you put in the same amount of time you put into engineering, you put that same amount of time into documentation. Ensure you're putting enough focus into that. So thank you to all of you listening. Thank you to Icons 8. I got some of my amazing illustrations from them. Thank you to the organizers, and thank you. That's it.
Okay, thank you. This is Henrik. So I have a couple of questions for you. Are you ready?
Yes, I am.
Okay, lovely. Here's a question. Excuse me?
Yeah, I can hear you.
Okay. Okay, they seem to come in a strange order here, so I'll do my best.
Okay.
how important do you think it is to translate documentation to other languages than English? For example, Swedish, Russian, Chinese, for people that do not speak English?
Yeah. All right. So, like I mentioned earlier, I told you to ensure that you create some kind of strategies and it's very per project. And like I mentioned also, each of your user persona comes to your project with different mindsets, right? So, if your project is originally English, let's say you're from England and then you speak English, right? And then I'm from, let's say, a country like, let's say, from China, right? I speak Chinese. You understand that I might not be able to flow so well with your documentation. And this is where analysis come in. You need to understand where your users are coming from. Until you do that, you won't know if your project needs translation or not. So let's assume you've done some survey, you've done some analysis, and you understand that you have like 20 users coming from China, you have like 50 users coming from India. You understand that people are coming from different regions where they speak different languages. That way you can now decide that, oh, I need to translate. So like translation is very important if your project needs it. If you analyze and run some survey, you understand that your project needs it, please translate. Like it's very important. Thank you. I hope that answers your question.
Okay, next one is would documentation be best as text with screenshots or videos on YouTube, and where to best publish it on the project's wiki, GitHub page, or a book?
Okay. It's quite similar to my answer again. Understand what works best for your project. Like by default, every documentation is in text, right? Like that's default. But now, if you understand that by text alone, documentation is not effective enough, based on your survey, let's say you get like 50% good feedback, right? You understand that you need to do something much more than just text. You need to understand that, okay, some of my users are complaining that they didn't really flow so well with text. I want something visual, or I want some working samples. It's possible your documentation just shows me how to set up. I really want to see how it is being used in real life, right? So I have a different mindset. So your survey will also help you understand which strategy to implement. So like there are several techniques. You can ensure you use illustrations and visuals. And if you look at my slides, I really love illustrations so much. So if I am reading documentation and you have so much visuals, like I'll be so interested to check it out more. And screencasts, videos, show me how to set up a project. It doesn't always have to be npm install this, npm install that. Prepare some screencast that shows me you and I see a human working on it and I can see it's going and then I feel like someone is talking to me. I feel connected to your documentation. Like it's more and it varies across several projects. Understand your project, run a survey on the documentation, and then come across come with several strategies and techniques you can implement. And then yes, you can host your videos on YouTube. You can host your documentation on GitHub. GitHub is one thing I recommend always. Like whatever tool you're using, most often they have an integration service allows you to integrate documentation with GitHub. Stuff like Gitbook or couple of other tools. They allow you to go to the documentation with GitHub. Make it public so you can also get contributors, like I mentioned earlier, and ensure that you're tracking every change you're making. And that way, yeah. So if you have any more questions, you can reach out to me. I'll provide links after now. I can answer your questions. So I hope this helps.
Okay, what do you think about organization conferences, meetups like writethedocs.org, etc.?
Okay, what do I think about those organizations?
Excuse me?
The question says, what do I think about those organizations, right?
Yeah, like www.writethedocs.org.
Okay, yeah. So writedocs.org is an awesome organization. I have this open source project I call Awesome Technical Writing. So like it's just a list of couple of technical writing tools, projects, organizations you can check out to improve your technical writing skills. So one of the organizations I mentioned there is Write the Docs. So they have conferences, they have podcasts, they organize meetups and all around documentation. And what you should note is you might not be able to attend those events physically, but you can attend their podcasts or listen to the podcast and some other of their initiatives, right? So I would recommend you check out Write the Docs. And I also have some other communities listed out in this project. I will share a link just after my talk and you can check it out. I hope this helps.
Okay, and the last question here. In your experience, which FOSS project has the best documentation?
Which project has the best documentation?
Yeah.
Wow, that's a really tricky question. That's a really tricky question, you know, because I've used several projects and then I've come across several amazing documentation. And then one like I can boast off anytime it's Gatsby JS. Like it's awesome. Like really, really, really awesome. Like I've implemented the Gatsby in like before now, and then it was really easy. Like it's just amazing. That's it. Gatsby JS. And then there's so much more, but like I would just vouch for Gatsby.
Okay, I guess I will leave to Johan to finish this. So thank you for now.
Thank you
Yep.
more. So if you have more questions, you can reach out to me on Twitter at I am Bolanjay, and I'll be so very happy to answer your questions. Thank you very much.
Thank you for coming. So we will wait for the next speaker for about 5 minutes. So we will be back at 3.
Welcome to foss-north, the virtual edition. We would like to thank all our sponsors and partners in this difficult situation. Our gold sponsors, Luxoft and Ansible by Red Hat. Our silver sponsors, ITRS Group and Make It Right. Our base sponsors, our partner projects, the open source community and the region of Gothenburg. And a huge thanks to our awesome community. This would not have been possible without you.
So welcome to the next session. This will be a pre-recorded session by Jason Hammond about managing risk and growth in open source software. Jason will be available for the Q&A session after the pre-recorded session. So ask your questions and prepare for an interactive session afterwards. Enjoy.
Hello. Thank you for joining today's webinar from White Source Software and Synergon on the topic of managing the risk and growth of using open source software. My name is Jason Hammond and I'm Director of Solutions Engineering for Channels at White Source Software. During today's webinar, we will cover the following topics: the growth of open source software use, the business risks of open source software use, and best practices for managing these risks. So let's talk about the first challenge, open source software use and its growth. You simply can't develop software at today's pace without using open source software. It's become a necessity, and that's great. Open source enables companies to build better products faster. After all, why should you reinvent the wheel when you can just go download that wheel from GitHub? As a result, the use of open source software used by companies is growing. White Source Software's analysis shows that 60 to 80% of an average application's code base is comprised of open source. But the fact that your team didn't write the majority of the code doesn't mean that it is not your responsibility to ensure that the components in your products are secure and compliant with your company's policies. In order to meet this responsibility, you need to establish a reliable inventory of all open source libraries used in your applications. You need to identify the known vulnerabilities of those libraries, and you need to make sure the open source libraries you are using are compliant with your company's policies. But it's not that easy. The problem is that verifying that each and every component is secure and complies with your company's policies is becoming increasingly complex. That's because information about open source components is scattered across hundreds of sources with varied levels of credibility, and most databases on the internet are not easily searchable. In addition, it can take a tremendous amount of manpower to do the research required to analyze the vulnerability and license information of all of the open source libraries across all of your company's applications. And it's only getting more and more chaotic. It's not getting any easier. Why is this? Well, in recent years, we've seen a spike in the number of reported open source vulnerabilities as awareness of these vulnerabilities rises. There is also the fact that as open source projects mature, the average number of transitive dependencies across these open source projects also rises. And the time it takes for bad actors to start attempting to exploit a known vulnerability is shrinking, meaning you have less time to fix the vulnerability before you may become a victim of an exploit. Let's talk about the second challenge. Open source software use can present significant risk to your business. How do these risks impact your business? Well, in the case of security vulnerability risk, by nature, the defects and vulnerabilities in the open source libraries you use will equate to defects in your product. Heartbleed and Shellshock are a couple of good examples of open source vulnerabilities that inadvertently impacted businesses. It's probably obvious, but security vulnerabilities can put your company at risk of inadvertently exposing sensitive or regulated data, which can result in regulatory fines or damage to your reputation. And security vulnerabilities can also put your company at risk of your services becoming unavailable or their performance degrading, making them effectively unusable. When your services are unavailable or not well performing, it can impede your company's ability to run its business, process orders, or provide the services that your customers rely on. Open source software licenses can also expose companies to risk. Open source software licenses have varying degrees of permissiveness or restrictiveness. If your applications use open source libraries with licenses that require your company to pay royalties, comply with copyright protections, or require you to publish your own code as an open source project, this can present a problem for your organization. Some open source licenses may impair your company's intellectual property rights to your work product that leverages the open source libraries associated with these types of licenses. You also need to ensure that the libraries you are using are in fact open source and have open source licenses. Non-compliance with open source licenses can mean legal issues or fiduciary issues for your company. Let's talk about the third challenge: how to manage the risk of increased use of open source. Your organization needs to get visibility and control of your open source inventory, the licenses associated with the open source libraries in your inventory, and the security vulnerabilities associated with the open source libraries in your inventory. So how can you get the control you need over all of your open source usage? Well, you can try to manage it manually, but then you're asking your development teams to track the usage of open source with spreadsheets and request approval to use open source libraries via email. These efforts will only slow down your developers, forcing them to spend precious time documenting their use of open source instead of building code. You can do nothing and hope for the best, but then you're exposed to security and compliance risks. Those issues don't go away. Or you can automate all the processes related to your open source management and let your developers focus on actually building products. Before we dive into the power of automated open source management, here's a snapshot of the scan analysis results of 250 applications. When presented with a comprehensive bill of materials of their open source libraries across all of their applications, over 75% of our evaluators were aware of only 50% of their open source usage. In most cases, the evaluators were aware of direct dependencies, but their biggest blind spot was the transitive dependencies in their code, which are far harder to track. Now, in a computer program, a direct dependency is functionality exported by the library that is referenced directly by the program itself. A transitive dependency is any dependency that is induced by the components that the program references directly. In other words, transitive dependencies are introduced to your code by the reliance of a library with a direct dependency on a library which does not have a direct dependency, and that becomes very difficult to gain visibility to. Almost 90% of the applications in our analysis were vulnerable to at least one security vulnerability, and 42% had more than 5 vulnerabilities. Our evaluators reported constant arguments between their R&D, security, and development teams. For example, when a security analyst takes product vulnerability data to a developer, It may be difficult for the analyst to provide evidence of the vulnerability to the developer, and even harder to direct the developer to the specific lines in their code that invoke those vulnerabilities. And finally, evaluators reported, on average, open source libraries were in use with at least one license that didn't meet company policy. That one license was generally associated with more than one open source library. Clearly, there is a business imperative to manage open source software security and compliance, and doing this in an automated way can have a significant impact on your business. Automated open source software management is more than just ensuring the security of your open source usage. Automated open source software management helps you build better software faster by consuming open source with no restriction or hesitation, and without adding unnecessary risks or friction to your development processes. And providing automated open source software management throughout the software development lifecycle can help you to address potential security and compliance issues earlier in the process, when it is less expensive to do, and provides the biggest and most positive impact on your security and compliance exposure as your product matures throughout the SDLC. Automated open source management should make developers' lives easier when they are relying on open source components. It should support pre-build stages of the SDLC to help developers find and fix vulnerabilities and compliance issues early on in the process, when it is easier and less expensive to make fixes. Automated open source management should also support security and compliance professionals. It should support the build and post-build stages to provide managers, analysts, and auditors with full visibility and control over the risk associated with the open source usage in their organization. At the plan stage, developers need to understand the vulnerabilities in the open source libraries they are considering using in their projects. So, as an example, your developers may be looking at common repositories of open source libraries that are posted on the internet. And there are loads of these available on the internet. In this case, we're looking at maven.org, and we're looking at a specific open source library, Jackson Databind, version 2.9.9. Now, developers should be able to gain insight into the vulnerabilities that are associated with these libraries and understand which licenses are associated with these libraries, and if those licenses may in fact violate a compliance policy of their company. Through browser-based integration, a developer will be able to see the specific license that's associated with the library, whether or not the library is up to date or not, some insight into any organizational policies that are defined by their organization that may be violated by this open source library, and awareness of the fact that there are vulnerabilities in this library, how many they are, and what their severity is. By getting this type of information, a developer may be able to, using insights provided by these types of tools, look at a newer version of the same library and be able to identify a version that does not have vulnerabilities and complies with corporate compliance policies. At the code stage, developers should be able to get information they can use to remediate security and compliance issues in the IDEs they use to write code. So in our demo, our developer is using Eclipse to build a project based on open source libraries. And we can scan the dependency manifests of the programs that are triggering the use of open source libraries and gain insight directly in the IDE of the fact that a specific library that's being invoked has vulnerabilities associated with it. It can even get insight into the fact that some of the dependencies are transitive, while others may be directly called. And finally, we can get a comprehensive list in a tabular format of all the vulnerabilities associated with this library. And using this information, a developer may choose to either not use this library at all, or they may consider using a different version of the same library, and they can make those decisions right here in the IDE while they're building their code. During the build stage, you should be scanning your code in line with your build pipelines to identify potential issues in the code repos used by your pipeline. You may even want to fail a build if it does not comply with the corporate policy. Now, as an example, your organization may be using GitHub Enterprise to manage your repos. If we take a look at a specific repo, the automated open source management tools should be able to scan the content of a repo when it is created, updated, or modified. And after that scan, you should be able to view any potential issues inside of your repo management tool. So in this case, we're able to see there are specific jar files that are part of our repo that have known vulnerabilities associated with them. And we can drill down into any one of these vulnerabilities in order to get more information about the vulnerability itself, maybe even give insight into the CVSS score, and even provide suggested fixes, such as maybe it's a good idea to update to a newer version of this library. In addition, once we've identified these issues, we should be able to help automate the remediation of these issues by triggering pull requests inside of the repo tool. So in this case, we know that by building a pull request and merging it with our repo, we'll be able to remediate the vulnerabilities associated with this Zookeeper jar file. So if we drill into the pull request, we can see, for example, that the pull request is designed to update the library from version 3.4.3 to version 3.4.14. If this is done, we are notified that we will be remediating these specific vulnerabilities, which will close out these specific issues generated by the vulnerability scan. In addition, in the pull request, we can take a look at which file is actually going to be changed and see what will change inside the file if the pull request is merged into the repo. During the deploy and maintenance stages, you'll want to rescan your code to ensure that no new security vulnerabilities will impact your open source libraries that are already deployed and in active use and are being maintained by your organization. And you want to make sure that no new compliance policies limit your use of open source libraries that are already being used by your applications. So in this example, you may take a look at your open source management tool in order to see high-level information about the libraries that are in use, including how many have newer versions available, how many libraries are you using multiple versions of, how many libraries have multiple licenses associated with them. And you may also want to see information from a management perspective of the security vulnerability alerts by library, how many libraries have alerts, and also by the number of vulnerabilities that have been identified. You also want to see comprehensive information around the libraries that, the licenses that are associated with the libraries in your inventory. If we drill down into our product, we'll be able to see, as an example, a comprehensive list of all of the open source libraries that are in use in this product, the comprehensive list of all the different projects that make up the product, the distribution of licenses, including their number and the percentage of libraries that are actually using a specific license, and also information about the restrictiveness or permissiveness of the license. And you'll also be able to drill down to see a list of vulnerabilities that are associated with those libraries. And you'll also be able to see a list of alerts that are associated with the open source libraries in this project. Now, today you may scan your code and identify that this is your current state, and you may remediate these issues. But as we know, new security vulnerabilities are identified, validated as known vulnerabilities, and published every single day. So it's important to keep in mind the fact that even though your scan today has cleared your application or identified issues which you have proactively remediated, tomorrow that situation may change when new vulnerabilities are released. And so having this level of insight, the comprehensiveness of a bill of materials of open source libraries that are in your products, and awareness of the vulnerabilities and licenses associated with those libraries is an important thing to maintain on an ongoing basis. You're going to want to do rescans to make sure that you remain secure and in compliance on an ongoing basis. Throughout the software delivery lifecycle, it is important to use your development and security analysis resources efficiently. If you don't, your teams may waste time focusing remediation efforts on vulnerabilities your code is not exposed to, while other vulnerabilities effectively exposed by your apps go unchecked. There's no reason to fix all the vulnerabilities inside of your product when only somewhere in the neighborhood of 15 to 30% of them actually impact your products. Every library has multiple functions associated with it, and each of those functions may be associated with one or more security vulnerability. But if your proprietary code isn't calling the functions that expose those vulnerabilities, they're not effective. So consider this. If all security vulnerability alerts are pushed to your software development teams, they may drown in those alerts, and they cannot possibly respond to all of the issues. They won't be able to keep up. And that means that prioritization of remediation efforts can become critical in your organization's ability to manage open source security. Companies need to prioritize vulnerability remediation efforts according to their impact on your applications. And this can be done by using open source scanning tools to create a call graph that shows a trace indicating whether your proprietary code is making calls to vulnerable methods, deeming them effective. If your proprietary code is not making calls to vulnerable methods, then the vulnerabilities are considered ineffective. And remediation efforts on these vulnerabilities can be deprioritized. Now, WhiteSource's research shows that up to 85% of the vulnerabilities in Java applications are ineffective, meaning that the vast majority of remediation efforts can be deprioritized, and remediation efforts can be focused on the vulnerabilities that most impact your product. So, as an example, if we take a look at our alerts, you'll be able to see the list of libraries and associated security vulnerabilities. You see these references, these shield references in the report. A red shield in this report is indicative of an effective vulnerability. It means that the scan was able to determine that your code base has an open source library in it with known vulnerabilities, and the scan was able to provide a trace from your proprietary code to a function in this library that exposes the known vulnerability. But you also see references to green shields. Now, the green shields indicate that the scan identified the open source library that has known vulnerabilities, but the scan was able to determine that your proprietary code does not make references to functions that expose the vulnerabilities in these libraries. Remediation of these vulnerabilities can be deprioritized. The yellow shields indicate an inability to find a clear direct reference from your proprietary code to the functions that expose the vulnerability. This often happens if your code is referencing classes, which may hide or obfuscate the direct reference to a function. But by providing the yellow shield, the report can indicate to your team that they should certainly take a look at and potentially make remediation efforts on these vulnerabilities in these libraries. Long story short, prioritize the red shields, deprioritize the green shields, and make some effort to take some look at the yellow shields because they may be, in fact, be vulnerabilities you are exposed to. With this type of awareness, development teams and security teams can more efficiently and effectively focus their remediation efforts. It is important also to keep in mind that open source libraries are used in containers and in serverless functions. So your open source management processes should also include scans of your container registries and container management tools, as well as your serverless functions such as AWS Lambda. You're going to want to be able to scan your Docker containers and your container management tools such as Kubernetes in order to identify the use of open source libraries in these containers and in these serverless functions, and to be able to highlight for you the vulnerabilities and licenses that are known to be associated with the libraries that are identified. In summary, when considering approaches to manage your open source libraries, you should be sure to consider these three key areas. Number one, completeness. Your open source management approach should offer a one-stop shop to manage all of your open source libraries, regardless of environment or language. It should also service the needs of all constituents of open source management information in your company, including security teams, development teams, DevOps teams, legal teams, audit and compliance teams, and of course, management. Number two, prioritization. Make sure the approach does not trigger alerts on false positive findings, wasting precious time researching problems that are not really problems. Also, make the approach support your efforts to prioritize vulnerabilities and their remediation based on their real impact to your company. And finally, number three, remediation. Your open source management approach should not only alert you on issues, it should also help automate remediation of issues by generating automated pull requests, offer suggestive fixes, and initiate automated workflows. With that, we thank you for your time and we'll be open to any questions that you may have. Thank you very much.
So that's the end of the pre-recorded session. So I'd like to welcome Jason here, and we have some questions. So
Hi everyone, this is Jason. Thanks for joining. I'm glad you were able to participate in this session today.
Yeah, thank you for your session. It was great. So the first question we have is, in reality, is it all that common that companies get sued for not complying with open source licenses? I heard the only copyright holder only the copyright holder can sue and not a user.
Yeah, that's true. It's not individual users who are suing, and the issue really ends up getting applied to the companies or enterprises that are using open source libraries. It's true that generally this is around issues either around copyright or royalties. Right, and so it's the owner of the open source library that's using the open source license will be the one that would pursue some sort of legal action. And that legal action may be trying to recoup royalties if the open source license has a royalty payment requirement. Or they may try to recoup money related to if there's a copyright restriction and an open source library requires you to publish your own code as open source. If you use an open source library that has that license associated with it, and you haven't actually published your code as open source and you've made money off of it, right, then that there is a risk that you could be sued by the license copyright holder for payment on the revenue you've generated using their work product.
Thank you. So the next question then is about tooling. So tooling is nice, but being hampered by corporate compliance policies makes me think that the problem is not the FOSS software, it's the policies. What's your thoughts on this?
Let's see. So being hampered by corporate compliance policies. Yeah, generally speaking, this is around if in the same scenario I was just talking about with a license that has copyright restrictions or royalty payment requirements, the organization may invoke a policy that says, we don't want you to use any open source library that leverages a open source license or is associated with an open source license that requires royalty payment or restricts our use. So a good example of that is the GPL 2.0 license. It's really restrictive, right? It requires you to publish your code as an open source project if you're using an open source library that has that license along with it. So as a corporation that's trying to build products to generate revenue, and wanting to use open source libraries to speed up the agility of the development of those applications, your corporate compliance policy maybe don't use libraries with those licenses. So that's really what the problem. It's not necessarily the proprietary software. It's really the utilization of the open source libraries that have these restrictions. And in order for your corporate compliance teams to be able to make intelligent decisions and guidance about how to enforce those policies, obviously visibility is important in terms of visibility of which libraries have which licenses associated with them. You can't make intelligent decisions about how to enforce these compliance policies without that visibility.
Thank you. So the next one is a bit cheeky. Is the scanner software in your showcase open source? If not, why should one trust what it scans?
Yeah, so it's not open source. And look, the history of this product is that the founders of this company built another company before White Source Software, right? So, and they sold that company to a large software company. And when that large software company acquired the smaller company, one of the things they required was a bill of materials of every open source library that was in the software that the bigger company was buying, and audit reports about the known vulnerabilities with those libraries and the licenses associated with those libraries. And they were asking for that information for the proprietary code as well, but open source libraries were part of that. So that's how they did. Our company, the founders of our company of White Source Software, identified that this was a need, because they went through months and months of compiling these reports. Now using a tool like White Source or another SCA tool, a software analysis tools, you can automate the process of getting that information. Why you should trust it. So the way that our software works is it will scan the code and look for the SHA-1 hashes of the libraries that are in the code, that are referenced in the code. right? So every file has a hash associated with it, and we can identify those that are associated with known open source libraries and compare the hashes of the libraries that our scanning agent finds in your code and compare it to our database. So why you should trust that is because the SHA-1 hash is immutable, right? If there's a match, then you know that the library we scanned is the same library that's in our database. Of course, it's true that developers may take apart open source libraries and use specific parts of it or create their own versions of it, and therefore the SHA-1 hash matching algorithm will fail in those cases, and that's why it's not the only one we use, right? We use other algorithms such as string matching on file names and other information, other indicators, metadata about the libraries that we can use to try and make those matches as well. But the matching of the SHA-1 hashes is the most reliable. So that's why you should trust it, right? On top of that, we have inside of WhiteSource a team of security analysts that spend all their time every day of every week doing the analysis of identifying the libraries that are published, the known vulnerabilities associated with them, and the licenses associated with them across a large variety of online resources, as well as proprietary resources, as well as our own scanning, right? We'll run our own scans in our lab and identify vulnerabilities that maybe haven't been published to the public yet as well. So those are the reasons why you should trust us.
Thank you. And then we have another one here. What in your experience is the most important skill to teach developers and other project members to enable them to work with open source?
Yeah, I think from my perspective, the word skill can mean a lot of different things. It could be, your coding skills. It could be communication skills. It could be a lot of different things. For me, the biggest hurdle that I see development teams run into is an unwillingness to be open and honest about the findings that they run into. If they identify a potential vulnerability, they want to try and resolve it before the rest of the corporation or the rest of the team becomes aware of the issue. In my experience, having open communication, being willing to be honest about what you are running into and what you are finding, and asking for help, right? And being able to communicate the findings clearly and consistently. Those are great skills to have, and I think that developers and development teams that are willing to document developers are great at documentation, obviously, but documenting things in a clear, concise manner and being open about what it is that you're seeing relative to things that could be risky is the best skills that developers need to have in order to have success when they're working with open source, right? So of course, these types of challenges cross into your proprietary code as well. So, just having your eyes open and understanding, if we're going to be trying to use open source software as a mechanism to speed up our agility and to add new features and to make ourselves more dynamic and responsive to the market, then you need to be aware of the fact that you may also be opening yourself up to risks associated either with vulnerabilities or with restrictive licenses, and go into it knowing that, and then use the best mechanisms that you have available in terms of both tooling and process to manage that risk.
Thank you. And then the last question is, what's the biggest risk to open source these days? Would you say it's patents, export regulations, or perhaps something else?
Well, yeah. So from a compliance perspective, it really depends on the nature of your business. So as an example, as a company building a lot of products, some of those products may be utilized internally only, right? Just by employees of your company, and they're not actually exposed to the internet or to your customers or things like that. And so, are there patent and copyright risks or export risks associated with that? Probably not. But if you start building projects that use open source libraries and they're exposed to the internet and to your customer bases or to your business partners, then all of a sudden export regulation for sure comes into play. GDPR comes into play. Any data privacy regulation will come into play. And so being cognizant of both the security vulnerabilities and the license restrictions that are applying to the open source libraries that you are working with is they're both risks. They're both risky from different perspectives. One is more litigious, right? When we're talking about the licenses and the potential attempts to recoup royalties or to get control over your work product. The vulnerabilities are going to be concerned relative to data privacy protections, and there are other obviously issues that security vulnerabilities address as well. Long story short, the vulnerabilities are changing all the time. New vulnerabilities are being published every day. And so from my perspective, I think that is the larger risk, because the the licenses that will impact things like attempts to control patents and export control licensing and things like that are pretty well founded and documented. And the bigger issue there is just understanding which licenses applies to the libraries that you're using in your code.
Thank you. And that was the last question. So I'd like to thank you for your session and all your answers.
It's my pleasure. Thank you for hosting, and we'll look forward to being in touch again in the future. Thank you so much.
Thank you. And we will reset shortly in preparation for the closing words. We will not wait until 4 o'clock for those. They will be in about a minute. Welcome all to the closing words of foss-north 2020, the virtual edition as we call it. I would like to start by extending a huge thanks to all our sponsors who actually made this possible. Our gold sponsors, Luxoft and Ansible by Red Hat. Our silver sponsors, ITRS Group and Make It Right. And our base sponsors, as well as the open source community and the region of Gothenburg. I would also like to thank you, our listeners. You are the ones who make this possible. You are the ones who make us go the extra mile and actually do this. So things didn't really turn out as we planned this year. The corona situation changed things just before we were about to pull off the biggest foss-north ever. After a couple of really intensive weeks of replanning, we were still able to book a number of our speakers, and we really appreciate them doing the hardest type of presentation you can do, sitting home alone, speaking to a computer screen, and knowing that there are potentially hundreds of people watching you. I wish to extend a big thanks to all of them. I also wish to extend a big thanks to our really brave lightning speakers who showed up a week early and helped us test the technology and shared their 10-minute snippets. So yes, from the bottom of my heart, I'd really like to thank everyone who showed up and who helped make this possible. I would also like to announce the next foss-north. Last year we announced the 2020 event. This year we will also announce the 2020 event, but the take 2. So we booked our favorite venue, start of November. The setup will be, as you know, a community day, 2 days of conferences and 1 day of training. And we hope to see you then. Take care, enjoy the summer, and hopefully everyone's well and we can meet in November.